Someone's got these new intros ready. We're almost there.
This has been going for like 20 hours.
This ends now.
Hey everyone, how are we doing? I updated OBS and it caused some issues, so let's hope nothing is wrong right here. I'm going to see if we're actually streaming. I had to change the encoder. It doesn't like the graphics card. Okay, so it looks like we're streaming. Looks like we're HD as far as I can tell. Cassandra, good to see you here. We're going to be doing some review. I'm actually going to, it looks like you can see my computer right here. I'm going to change this. Look at it. We're going to change a tiny bit. Ooh, there we go. Perfect. Just making sure things are excellent. Sometimes I make some small updates of the weekend, but updating OBS could have caused some issues. Cassandra, do you have a chapter you would like us to start reviewing right now? We're going to do the Kahoot, probably about an hour and 30 minutes. Good afternoon, Chloe. Great to see you here too. Let's route some UBOT points. If you are here, good afternoon, good evening, wherever you're at. But who has questions to start? Name the chapter and we can start it up. Put on a little chill music. What chapter should we start reviewing right now? You name it. We will jump on into it and start reviewing. OBS has a little red dot, I think, when I'm live to inform me. And I'm just like, being like, what's going on? We've power cycled the router and modem. We've updated OBS. Probably need to update the graphics cards. Trying to narrow down any sort of lag issue. It is your call on the chapter. We've got chapter 7, chapter 8, which are both regression. We've got chapter 10, which is on sampling. We got decision trees, which is a theory chapter. We have chapter 12, which is on sampling methods. We have chapter 13, which is on sampling distribution and sample proportion. We have chapter 14, which is on the sampling distribution of the sample mean, which will be covered tomorrow. So there's a lot on this test, a lot of material. I do want to point out, if you're watching this stream right now, Ubot's going to put in the chat review too, but name a chapter. Chapter 7, chapter 8, chapter 10, chapter 12, chapter 13, chapter 14, or decision trees. 7 and 8 are very similar. Mubot's got in the stream right here the place to go to review. We'll take a look at that real quick right here. But name a chapter. Name a chapter. What chapter shall we review? Let's see. You name the chapter. We will go and review it. Let's go over and look at the main screen real quick. Here we go. So here we are. 13. Oh, 13's a good one. So let's go over and take a look. This will be chapter 13 review. Going to put that in the notes. So 345, chapter 13. Sampling distribution of sample proportion. So the number one thing to do. What's up, Troy? Good to see you here. Bronze Cat. Oh, make it happen. Make it happen. So number one thing to do is to go to a few spots right here. One, go to the formula sheet and let's look at the formula sheet for chapter 13 so far. Okay. So you should know all of this notation. This is chapter 13 notation. Let's go ahead and grab this right here. And let's start by just doing the notation for chapter 13. Kristen, great to see you here. We're doing some chapter 13. We can do whatever chapter people want next, but this is chapter 13. So I'm going to highlight some stuff in different colors. I want you to tell me what they are. So tell me what these things are in the different colors. You're just seeing different things on here. So tell me what they are. That's pretty much everything. That's an easy one right there. So what all do we have on here? Oh, on color. Someone name a color and tell me what it is. This is good practice for you right here. So you can see the different things and what they are and how they apply. And so what all do you see on here? Running out of colors that we're doing. What all do you see? Like a magenta. Oh, Avery, great to see you here. We're going to first start by talking about, this is chapter 13. We're talking about the notation for the sampling distribution of the sample proportion. So chapter 13 is the sampling distribution of the sample proportion. That's what chapter 13 is, the sampling distribution of the sample proportion. Anyone know any of the notation on here, whether it be P, whether it be Q, whether it be N, whether it be SDP hat? Any of this right here, like how problems would read, how they would look, because this is going to help us as we do like example problems from this and understand how to use this chapter. Oh, great job. Troy's got a bunch right here. Troy starts out by saying the blue one is P, which is equal to the true proportion. When you're doing a question that says something like the true proportion, it would say something like, i.e., we know that 20% of UT is from Georgia. I'll zoom out a little bit here. That's good. We know that 20% of UT is from Georgia, or one of my favorite ones. We know somehow that 70% of students love Taco Bell. This means it's something true we know about the population. It has to be a question that is categorical the way it was asked. So this is the important part right here. We have to know this. And then we have some examples here. This is like the best way to understand these is to talk through examples. And ooh, we got some great stuff from Kristen right there. Great work, Kristen and Avery and Troy. Good practice. So the next one, yellow, is its complement. And we'll do some blue right here. So this is the blue one, which is going to be the true proportion. And you can see that's used for the standard deviation. And then Troy also said that Q, I think they're lowercase. I just used it's P and Q. They're lowercase because Q would look different. It's not uppercase. Really. Q equals to complement of true proportion. And so if P is 20%, what is Q? This is great practice. And Laura, excellent work right there. And Calvin, great to see you too. Everyone, 100 points. Keep it up. If P is 20%, what is Q? These are the things we should know, like that when we get to the test, we're like, oh, P is 20%, Q is this. So what is Q if P is 20%? So try to solve that right now. We're just making sure we understand how to use these and what it means. And great work, everyone there in the chat, practicing along as we do this. So we're going to put another IE right here, IE, and then we're just going to copy it. And it's just a complement. Like we know 80% of UT is not from Georgia. And 30% of UT does students do not love Taco Bell. I do not know why. They've got a new breakfast menu. I still haven't had it, but come on, it's Taco Bell. So once again, showing us that P and Q are complements. Please notice how these numbers are linked right here, that if 20% of UT is from Georgia, 80% is not from Georgia. If 70% of UT students love Taco Bell, then 30% of UT students do not love Taco Bell. They're just complements. Everyone spam the chat with it. What do P and Q add up to? Hence their complements. Good review of chapter 12. P and Q add up to what? Spam that chat. Another 100 points. Hey, Priya, great to see you here. Spam the chat. They add up to 1 or 100%. Either way you look at it, 1 if you do it as decimals or 100% if you do it as percent. Great job, Juanita and Arden. Great to see you here. And also Kayla. Good to see you, Kayla. Okay, and the next one we have, someone might have mentioned N. N is going to be super important. What is N? N is how many observations we talk to, really. Also known as sample size. So this would be, and this is not relative to the population, but we talk to 200 students. We talk to 800 Tennesseans. This is not the population size. This is the size of the amount of people we speak to. Great job, Avery, right there writing sample. Great practice. So it's pretty much, I don't know, spelling thing. There we go. Those are examples. Make sure to know how to see it in questions. So that was orange. We're going to do some example questions here in a moment. Maybe we'll do like a Canvas content from it. That wouldn't be a bad idea to do a Canvas content or two to practice these. And next we see we have not done this right here. What is P hat? Now P hat has the hat means estimate, or sometimes it means predicted, like from a line of predicting, like Y hat means predicted Y. Could be estimate from a model too. But in this case, so P hat is the great job, Maria, right there, the estimated P. Mu P hat is the mean of the distribution of the sample proportion. So you can call it sample proportion 2. It's the estimate from a sample, and it's really good to maybe put it after this. So let's insert P hat right here. We're going to make this look all nice and purdy right here. We're going to go to insert, and I'll disappear at the end so you can have it all. Try writing this with me. Practice it as we do this. And where's my accent? It's going to be this one right here. It's going to be me. There we go. P hat equals to sample proportion. There we go. And go over here. Okay. And that is what P hat is equal to. There is Q hat. Kaya, great to see you here. Awesome. And so that would be in our sample, 20 out of 100 students are, let's not do that. 24 out of 100 students are from Georgia. Now, here's the issue. Oh, Mewbot's on. Leo, great to see you. Oh, we got everyone here. Love it. It's like Smash Bros. Everyone's here. What is p hat in this example? In this example, awesome, Kristen. What is p hat in this example? In this example right here, so I'm writing an example thing. What is p hat? So what would p hat be in this example? So use the numbers on the screen to find p hat. Oh, okay. You guys, everyone's too nice to me. Kinda. Priya's good answer, and great answer, Maria, right there. It'd be more like p hat. We'll write p hat would be 0.2. Another example would be talking to 48. No. Talking. Oh my gosh, 200 students and 48 are from Georgia. Okay, what would p hat be in this example? Great job. Don't worry about it. Annabelle, great to see you here too. What would p fats be in this? What would p hat be in this? We'll make it look better here. There we go. Really? I didn't want to copy it. What would p hat be in that example? What would fats be in that example? It would still be 0.24. We did. I was ready to go, and I was like, why not? Let's just do it. You can rewind live, and this is recorded if you want to check anything out. P hat here would still be. We don't want that. Would still be 0.24. Now, I bring up these examples right here for a reason, because who can tell me what 24 is in notation? This is a thing many people forget, and we're practicing notation right now. Then we're going to do some Canvas content to review for the test, and also help with your Canvas content due tomorrow night. Who can tell me what 24 is in that example? Who can tell me what 24 is, which is not on the slides right here? 24, and I'll disappear at the end of this. 24 is going to be what? Great job, man. It's X. Avery, great work right there. A lot of people forget this one. 24 is X, which is the number of successes. It's a very commonly forgotten, really, no line right there. 24 is X. It's the number of successes. Great work, Avery. 100 points for everybody. Keep practicing. It's just the number of successes out of the number of trials, with 100 being the students we sample right there. So, and great work. You know what? We're doing some 500 points. I love when everyone's cheering everyone on. I mentioned I did the presentation to educators, and I said to them how like some students, so I did my presentation on Thursday at the symposium. There's Mewbot right there. And I said, in my class, we get points as a team. And I said, we cheer each other on. They're like, what? And I was like, yeah, everyone's like, great work, great answers. And if someone's answering all the questions, they're like, do it. So they're like, you're like, come on, get those points. Great job. I love it. More points. Allison cheering everyone on. What else do we have on here? Please tell me if I missed anything. We got the standard deviation of p hat. This is read as like a sentence right here. So when you see SD p hat, it's just the variation. Why do we need to find SD p hat, and why do we need to find mu p hat? Why do we have these quantities of SD p hat and mu p hat? So why do we need, you got it, Ellie, right there. Why do we have these values? Why do we have those values? I'm going to try to insert the Greek symbol. Where's mu? I used to know where it's at. Mu. There's mu. Why do we have this stuff? What's the point, everyone? What's the point? Both these values, SDP hat is spread and mu hat is the center. Yes. Maybe I should put them in reverse order because it's usually mean and standard deviation. So the point of having these values right here, really, the point of having these values is to know the mean and the standard deviation of the distribution, meeting the conditions of like random, 10%, success, failure, to draw our curve, right? So these are the values, the mean and standard deviation for the normal curve, and if we meet the conditions, curve. So this is a really good note right here. Repeat again after me. Why do we need to meet the conditions as I color code stuff? Why do we need to meet the conditions? What's the point of meeting conditions when it comes to the curve. Why do we need to meet the conditions, all three? And then we're going to do some Canvas content. This is chapter 13, notation. And there it is on the screen. I'll zoom in a little bit maybe so we can get a nice screenshot of it. There it is all for you right there. If you want to screenshot it or practice it and write it down, I think that's everything. Why do you need, and Allison, great right there. Allison, another 100 points. And we'll be doing some Kahoot here in about an hour and a half or so. If we meet all three conditions, random, less than 10%, and success failure, then it'll be normally distributed. The conditions have nothing to do, hint for Canvas content, with finding p hat. How do we find p hat, which is not on here? But it's kind of alluded to in this question. What is the equation for p hat? Avery with some crab rave jump scares. What is the equation for p hat? This is a good review of chapter 13 right here. All the notation, all the equations. Great job, Avery. X over n, successes. And that's in this one right here. We did a little x over n, no x hat. X over n p hat review right there. So good practice. Have this written down. No examples of each one. Know why we're using it. Great practice. Okay. So we're going to do some Canvas content right now. We like doing a little bit of Canvas content. So here we go. One moment. But how's everyone doing? Can X represent? Either one. It just depends on how you want to name it. There's a formula sheet for the exam. Make sure to go to, review 2 has the formula sheet. If you can't find it, I'll show you it's in a moment. But how is everyone doing tonight? Put how you're doing in the chat right here. A little chill music. I'm going to get Canvas content open while we're listening to this. Oh, we were on the formula sheet. That was the formula sheet. So I'll show it again if you need. But that was the formula sheet. And so knowing how to use the formula sheet is very important. That was the formula sheet. We will be checking it out more later. Gotten a lot of good sleep this weekend. Who's had a good weekend? It's been a good weekend. It's been a nice time. Got to play a little bit of video games. Caught some Pokemon. Not that I play Pokemon Go every day. Anyone else play Pokemon Go? Did you get any mudkips today? Did you get a shiny mudkip? I'm doing okay. Eating some Chipotle. Oh, Chipotle is so good. Did you get a bowl or a burrito? I'm all about that bowl. Chipotle bowl. Because burrito, it's like, it's a little, I don't know. I'm not smart enough to eat a burrito correctly, but a bowl is just like, it's nice and easy. Need to add you? Oh, send me the thing on Discord. No shinies? I will give you a shiny mudkip. Don't worry. I have people train me Pidgeys. I forgot it was community day. I'll give you a shiny mudkip when I'm back. I caught a lot, and I did the last one. How long is this? We'll be doing the Kahoot in about an hour and a half. Mudkip community day, Joey says right there. You bet. A lot of mudkips. I got two 98% mudkips, and I was like, where's my 100% mudkip? I'm a little crazy. Getting close to level 48. I'm a little crazy. Let's go do this. Let's go do this Canvas content right here. Happy birthday right there to Troy. Here we go. Awesome stuff. I think awesome stuff. For the success failure, do we need to know to show amount? You might have to, Allison. Sorry, I missed the question right there. To Allison's question, you might have to. Some questions might ask you if it's passed or how many successes, how many failures. You need 10 successes, 10 failures. We could do some questions on that. Feeling nervous, Casey? We're going to do a lot of practice right here. We took a little break right there. Everyone's wishing some happy birthdays right there. I think it was Troy. And here we go with a Canvas content. Now, one of the reasons why Canvas content is so important is because Canvas content has what's on it. Canvas contents. Oh, it's Avery's. Happy birthday, Avery. What does Canvas contents have on it? Why are we so focused on like, ooh, we got to ace this Canvas content? We got to know this. Annabelle's right and Allison's right. It's got some test questions right there. So all things being equal, the larger the sample size, the smaller the standard deviation of the sampling distributions. Go to your formula sheets. Do I want to look at, and I'm going to write some things on it. For this question, which number should I look at? It says all else being equal, larger sample sizes means smaller standard deviations. Where should I look at for it? 1, 2, 3, or 4? Start spamming the number in the chat. For this question, it said all else being equal, larger sample sizes means smaller standard deviations. I should look at 3. Kelvin, great work right there. Because it's saying standard deviation. So Rock knows.
It doesn't matter.
Whichever one, it doesn't matter which one we're talking about. We're saying all else being equal. So we know we're looking at standard deviations, and you get the formula sheet on the test. So where is the standard deviation is in the, where is the sample size? Is it in the numerator or the denominator of the equation? Is the sample size in the numerator or the denominator for the equation? So if you have your formula sheet, you can look at it and be like, it's in the denominator, right? So it's in the denominator. And so since it's in the denominator, which is the bottom of the equation, if it gets larger, no worries, Kristen. If it gets larger, then what happens to standard deviation? If sample size gets larger, like you just say you increase this, the equation will get water. So if you make n larger, then standard deviation gets smaller because you're dividing by a bigger number. It's like, imagine I take your money and divide it by 100. Would you like that or not? If I took your money, like if I take your dollars, so I say, I'm going to go to your bank account, and here's your dollars, and I'm going to divide it by 100. I would not, Luke would not like that. Luke says no. So your money would get smaller. Are you still opening the exam for all day? Not for all day Wednesday. If you signed up for a morning makeup, you have the morning makeup, but let me know if there's issues. We have people sign up for the morning makeup. It's not open all day Wednesday. It's open 7:30 to 11. But there you go. You can try Brian. Don't take my money, Tiny Brian. No, he'll be here for the Kahoot. Okay, so that question is definitely true. All else being equal, larger sample size means smaller standard deviation. The three conditions for the sampling distribution must be met in order to calculate p hat. How do we calculate p hat? How do we calculate p hat? Basically inflation. Kristen's like, it wouldn't change anything. Probably about an hour and a half, Caitlin. I think we'll start at 8:30. 8:30 Kahoot. X over n. X over n. You can't use notes on the front. You're not allowed to like give someone your formula sheet afterwards. You probably can write on it during the test. You can have scratch sheet of paper during the test. We can't stop you from writing your formula sheet, but don't have notes. Like, don't have notes. Don't put notes on your formula sheet. You can have the formula sheet, but no notes on it. Like before the test. Robin Taylor. Hey, Robin! Oh, that's such a cool Robin. 100 points. Robin, so good to see you. Everyone give shout outs to Robin. We're going to throw some crazy points in the chat. Robin, so good to see you. And so people are putting the formula in the chat, x over n. So when you did this right here, x over n, does x over n need anything to calculate? There's our thing from earlier. Does x over n need anything to calculate? Do we need conditions? Do we need any conditions right here? Have I mentioned to you conditions? I say something like, we love talking about Taco Bell. 80 students out of 90 like Taco Bell. We went and talked to 90 students. So tell me the sample proportion. And we didn't talk about conditions right here, right? 80 students out of 90 like Taco Bell. So tell me the sample proportion. I'm doing it in my head right now. Boop, 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 boop. Grab your calculator and tell me the sample proportion. Who's got it in the chat? 80 students out of 90 like Taco Bell. I don't know what the other 10 are doing. 80 out of 90 students sampled like Taco Bell. 0.888889, correct. You didn't hear me? No worries. There it is right there for you. And what are you telling me right now? What statistic are you telling me? This is from a sample. So what have you just told me? And this is a key point of confusion. So you've just told me what? You solved this equation. And what did you just tell me? What statistical value did you just tell me? You just told me, great job, people putting in the chat. You told me p hat. Every p hat will always have with it a what? I'm going to point to it. Anytime you find p hat, every p hat will always have with it a what? Every p hat always has to have an associated this, and I'm showing you right here because it comes from this. It's a sample proportion, so every p hat must have a what if you're talking about it. Every p hat, who can finish that sentence? Every p hat, if we're talking about p hat, sample proportion, every p hat must have a sample size, exactly. And then we'd need to know the number of successes too. Now I will do it a confusing way right here. Watch this. This is a confusing way. We talked to 200 students and 40% of them are from Knoxville. What was X? So take a moment and we'll color code this here and think about what you have right here. So what is 200? This is good notation practice. So just spam the chat and I'll highlight stuff right here and we'll practice. Great job, Kaya, right there. Kaya, 100 points. You're solving it. Correct. Great job, Annabelle. Also, you see that 200 is the sample size, and then this is p hat. So you can actually rework the equation algebraically to solve for x, which interestingly enough is a lot like the equations when we do n p hat and stuff like that, or np right now. Later on we'll do it. But great job on 80. 80 is correct. And then what could you do to check your mathematics to make sure you're correct? Like, let's say you're like, let me check my mathematics. What could you do if you think x is equal to 80? What could you do to check your math? Like, you're like, I really want to double check this. Great job, Charles, right there. You are right. We could just double check it and be like, okay, that should equal to p hat. If you're worried you did an algebra mistake, you got it right there. So excellent work. That is correct. Let's take a look at the next one. And great practice. Remember, we're working on notation. So this is very false. There are no conditions for p hat. It's just x over n. Why do we check conditions? Like, we don't want to just know the answer to the question. We want to know why we check conditions. And we were saying it earlier. So write this on a note card if you don't have it. We check the conditions such that we know the curve can be drawn by a normal curve exactly. To model it with the normal curve with a mean and standard deviation, as Avery's saying right there, 100 points, Avery, you are correct. I always spoil everyone with the mu-bucks. You know how it goes here, Charles, for the normal distribution. So this is false. There's no conditions for p hat. It's just x over n. All things being equal, wait, is it a reverse of the first question we got? All things being equal, the larger the sample size, the smaller this. All things being equal, the larger sample size, the smaller. True. Okay. Okay. The sampling distribution of the sample mean, which we'll be covering tomorrow, will always have the same blank as the original distribution. Now, where would you, if you're looking at this question and you got no idea where to go, what would be your way of solving this question? It says the sampling distribution of the sample mean will always have the same blank as the original distribution. And we'll be hearing more about this tomorrow. What would be your, where would you go? Where would you go? Some people are putting some right answers in the chat, but if you're like, I don't know where to go for this, you're like, I have no idea what to do. I would go to the formula sheet. So I would go to the formula sheet. Great job, Allison, right there. I'd go to my formula sheet. And let's take a look at the formula sheet here. I think we still got it. And so we have some stuff on here. We're missing one of the things. This is the formula sheet portion of it. Make sure to go to review 2 for the formula sheet. And let's take a look. Which row does this question ask about when it says the sampling distribution of the sample mean? Is it talking about row 1 or 2? Is it talking about row 1 or 2? Is it talking about row 1 or 2? It says the sampling, great job, Maria, right there. So we know we have this right here. Now, it doesn't say anything about the shape on here. I will comment about that on the very end of this. And remember, we are doing an in-depth of this chapter tomorrow. And we're going to practice more. So we know we have this stuff to look at. This is a z-score, which tells us how far away an observed sample mean is from the, it says hypothesized, but it's just true mean at this point. And then standardizing the distance by standard deviations. Great job, Julia, right there. Excellent work. And Sydney and Grace. So many people here. Awesome. And that's the standard deviation. Now, what happens, is the standard deviation the same? Like, here's the original. This is the true standard deviation of a population. And the standard deviation gets water as n gets larger. Because it says it'll have the same as the original distribution. The standard deviation is going to probably get, and Robin put some great stuff in the chat, unless sample size is 0, which is impossible, but it's fun to think about mathematically. It gets smaller, right? So we're going to see a decrease by square root of n in size of standard deviation. So standard deviation is just wrong. So we've eliminated, we'll put a red pen on here just for a moment. We've eliminated standard deviation as an answer because that's going to get smaller by a factor of square root of n. But look at the first thing, the mean. That was, oh yeah, oh, the $0. Nice job, Robin. So the mean says what? Now it's kind of, it looks like a lot here. I do want to say something. You will not multiply. I've seen people say, oh, this is an equation. No, this is a phrase. The phrase right here says the mean for the distribution of the sample mean. It can also be thought about what we expect to see for a sample mean. And it sounds more complex than it is. Tell me this much. If the average UT student is 5'7", and you talk to a student, how tall would you expect them to be on average? If the average UT student is 5'7", and you talk to a student, how tall would you expect them to be? Just you talk to a student. How tall would you expect them? 5'7". Maria, great job right there. That's what I expect. Well, that's one student. Now, what happens if I said, what do you think the average height of 100 students is, which is the sampling distribution of a sample size n? So in sampling distributions, we have the idea of a sample size and the average of that distribution. So if I said, what do you think the average for 100 students would be? If you're still putting 5'7", that's the right answer. Because it's like, well, I guess if one student's 5'7", then the average of 100 students would be about 5'7". So what do you think the answer is? The distribution will have the same what as the original distribution. So what do you think the answer is right now? We'll cover the last one here in a second. The distribution of the sample mean will have the same mean as the original distribution. Like if I told you, when I go to Taco Bell, my average meal costs $6. I don't know. And so if I go to Taco Bell 100 times, what do you think the average price will be when I average together those hundreds? Like a random sample of 100 Taco Bell meals from Brian would probably have an average close to what? What do you expect? If Brian regularly pays $6 at Taco Bell, then if I average together 100, it'd probably be about $6. And that's the mean for the distribution of 100 visits. Like the average of 100 visits would be close to $6. The standard deviation would change. And there's one other key concept that changes here. Where we're not just doing the Canvas content, we're learning all the material behind this. The last concept right here, and this is very important, goes to the third condition. 3 conditions for sampling distribution of sample proportion of sample mean. Oops. Okay. Everyone, you know how it goes in my class. Here we go. You ready? Get ready for this tomorrow. Get ready for this for the semester. Condition 1. I'm not hitting the button until you say it. Condition 1. Give me some condition 1 right here. Who knows condition 1 right here? Condition 1. Start it up. You know what's about to happen. Condition 1. Condition 1 is random. So we have to randomly select individuals or things from population, whatever we're talking about, or randomly select observations. It's not always observation. It's not always about people. It can be like random trips to Taco Bell, random widgets if we're at a factory. That's a classic stats thing right there. So that's the first condition. There's technically no order, but I do like doing it this way because there's something we have to do in a moment. Condition 2, people are already saying it. What is condition 2 as I change the way this is? Don't know. What is condition 2? Who knows condition 2? Put it in the chat right there, 10%. And what do you mean by 10%? You are correct. Let me throw those 100 points. You are correct. Kobe, great to see her too. And Priya and Caitlin and Kristen and Arden, excellent work. What do you mean by 10%? What 10%? So 10% condition, sometimes called the less than 10%, no more than 10%. And great job, Kaya. Wow, Troy and Kaya, like perfectly in unison right there. And Emma, great work. No more than 10% of the population is sampled. So, and look at Troy, great answer, or Avery, excuse me, great answers. We do not sample more than 10% of the population. So quick examples on this, make sure to practice. Brian goes out and talks to 10,000 UT students and only 50 of them play Pokemon Go. I promise there's more than that. Play Pokemon Go. Do we pass the condition? Now, technically, I'm doing sampling distribution and sample proportion, but I feel like this is where people make mistakes. Let's take a vote in the chat right now. Take a vote. Do we pass the condition with a yes, no right there? Just take a moment and tell me, do we pass the condition? I'm trying to see a better song than that we can play. Do we pass the condition? I'm trying to throw every trick in the book I know at everyone to see if we do it. Technically right now, the way the question is phrased is sample proportion right now, because I asked a question dealing with proportions. It's a 50-50 split. Who wants to explain why we pass or not? This does have enough info. This good, Charles, good comment right there. It does have enough info. UT has about 30,000 students last I heard. 33. Oh, take a zero off, Kristen. 30,000-ish, right? So who wants to explain? I want you to put a capital no or yes in the chat and then explain. I want a capital yes or capital no. Be careful. Put a capital no or capital yes. Take a moment. This is why I do these ones, because I see people miss this on the test. We got steps to this. Troy, I'm throwing Troy some 500 points right there, and everyone getting those 500 points. Troy, look at Troy's answer right there. Great answer, Troy. Troy said 10,000 out of 30,000 is 33% of the population, so no. Now, I tried to trick you right here. I did something commonly done in these problems, not trying to trick you, but the common mistake is this. What? Oh, I'm not on the highlighter thing. What is 50 in this problem? So that is n, but what is 50? What is 50? This is the common mistake. Oh, that's all right, Charles. Oh, yeah. Oh, yeah, Charles, we probably need to tell you that. Good point. Not necessarily sample frame, but population. God, good answer. Good. And Allison, good. Allison, 100 points right there. Good job, Allison. This is X. And maybe I should have said UT has 30,000 students in it. That'd probably be a better test question. We talk about how to write test questions, like it's got to look good. But that would be used to find the sample proportion. So what do you need to look at here? You need to know two things. Let's put down some notes on this because there's a common error. Okay, to solve these questions, you need to know. You need to know size of sample. Then you also need to know what? Size of. These are the things you need to know. You have to be like, I gotta know the size of my sample. Gotta know the what else. What else must you need to know? Size of population, Allison, great work right there. And then is my sample less than 10% of population? So identify those things. You need to know the size of your sample. In the previous problem, it was 10,000 we sampled, and the size of the population is 30,000. I do agree with Charles right there. Charles, 100 points. If you didn't know that, you are correct. The problem would not give you enough information. So Charles, great answers right there. And then just do the mathematics here, and we'll do it as the full thing. And this would be a no right here to the example problem we used. So good stuff and good practice. And this gets us to the last condition right here. And this is a good review, especially for the test. There we go. Condition 3. Watch this magic. Control Shift C. There we go. Cool. Well, you would be given it. You would it would give you some ability to know it. So anytime, or it would say like you can't solve it. Good questions right there. Priya, 100 points. Thank you for asking. We would have, what is the third condition? Does anyone know? Now, Kaya, this is I'm kind of asking a trick right here. Kind of, Avery. So Allison points something out really well right here. The third condition for proportions, and let's put that up here. Success / failure. And this would state we have at least 10 successes and 10 failures found by NP and NQ both greater than or equal to 10. There we go. But there's something that changes right here. Let's highlight this because, and we mentioned this last class, and I'll just say it since we'll be doing it tomorrow. If we're doing the sampling distribution of the sample mean, this is where your world changes a tiny bit. So take a look at, we're doing the sampling distribution of the sample mean now. The population is not given, you can, oh, nice job. Robin, 100 points for Robin right there, giving some great advice right there. And to figure out what is the minimum population size would be needed. Exactly. Robin is just, we're making Robin a mod right here. Robin, you are now a mod on the channel. Thank you, Robin. Giving some great advice to, if you don't know it, you can also kind of estimate what would be needed. And think about this. How big would UT, if we sampled 10,000 students, how many students would there need to be at UT for us to sample less than 10%? So think about this. If we have like 10,000, oh, it means your name is Blue and you can moderate the channel. Welcome to the mod squad right here. Got the mods. How many students would there need to be at UT? It's like 5 billion neighborhood there. At least 100,000. Great job, Christian and Charles and Kristen. Excellent work. At least 100,000. And so Robin's kind of pointing that out right there, that you could divide it or multiply it by 10. And this is the sample size right here. to give minimum population size. So minimum population size needed. So we could add that as a bullet right here. So this is just another way to kind of calculate it to say, like, what is the minimum population if it wasn't given right there? Just another idea of how to do it if we didn't give you that information. You might be like, so good question right there, Priya. We just took the 10,000 we sampled and multiplied it. Here, we'll show it over here on the side. We talked about we sampled 10,000 students. We multiply that by 10, and this would be the minimum size of UT population to meet the condition. Does that make sense, Priya, right there? You're welcome. Good work. And here's the thing, though. The third condition, we have something we say, and we'll get, someone started this. I'm going to see if I can find it. I'm going to start it this semester. You know, what do we do? What do we do before we get to the third condition? This is what we'll do. Brian has started the trend. It was a student who came up with this. What do we do? You got it. You'll hear in Brian's accent. We pause. So what do we do? Before we get to this third condition, what do we need to do? We pause. So we got to pause before the third condition. My accent's usually not that strong, but a little more fun with it. So we pause. What do I mean by pause? A lot of people will just go straight into the third condition. You have to think to yourself, what kind of data am I working with? We'll put this in red right here. Pause. We'll also add it up to here when you're checking your conditions. And so when you're doing this, it's nice and easy till you get to condition 3. World's a great place. Boy, I don't know how to say that. Poise. So we pause. The third condition down here is going to be, what do we call this one? I think it's large enough n, right? Large enough n. It deals with the central limit theorem. It's the large enough, and technically it should be lowercase n, because we're talking about large enough sample size. The sample size needs to be large enough such that the distribution of the sample mean is nearly normal. If normal, 1 is large enough. If skewed, 30 is large enough. If, we almost made it. If very skewed, 100 is large enough. If super duper ridiculously skewed. Avery, great job. People were mentioning this. Someone was saying, wait a minute. It's like large enough sample size. There's that 30 you were talking about. Avery was mentioning this last class, and I was like, I think you're talking about the next chapter, Avery. So Avery, you're going to see something super cool right here. There we go. We got it all on one screen right here. Good practice. I want to show you something really awesome right here. Give me 2 seconds. And this has been a really, really good review of probably some of the toughest chapters. So give me a second right here. Here we go. Okay, you ready? This third condition applies to the sampling distribution of the sampling what? The third condition here, known as the large enough n condition, applies to the sampling distribution of the sampling what? The third condition, known as large enough n, have a note on this, the third condition, exactly. Oh yeah. Great answers, Robin. The sample mean. Now, if we're back here at sample proportion, then the third condition is what? If we're back over here at sample proportion, then the third condition is what? So notice this. We're going to make it super clear right here. If you're over here at sample proportion, what? A lot of people just spin through these and they don't know the difference. Sample proportion, success, failure. I want to see chat spamming this. I want to see proportion equals success/failure. I want to see people spamming that. And then I want to see down here, I want to see you spamming that mean. This is the practice. We got to write it. We got to practice it. We got to put it in our notes. And if it's mean, then we're doing large enough n. Great job right there, Leo, practicing. Proportions, third condition is success, failure. And Caitlin's putting that when we do the mean, the third condition is large enough n. So take some screenshots if you need right now. Write it down. Your number one way to practice this is going to be to write it down in your own words and to repeat it, to say it. If we're doing the sampling distribution of sample mean, the third condition is the large enough n. We're going to show that here in a second. And then if we're doing the sampling distribution of the sample proportion, the third condition is the success failure. And we have right there listed what the success failure condition is, some shorthands, and some ways to practice it. Great job right there, Leo, practicing. What does this condition mean? You're going to hear this more tomorrow. Once again, the lecture is on it tomorrow. Here's what it looks like. How does that original distribution look up there? You ever seen that curve before? Dr. Hell, you got Kaya. How does that look right there? What's that shape? Looks pretty normal. Great job, Leo. It looks pretty normal, right? So watch this. I'm going to go and I'm going to take 10 observations from this. 10 observations. Do you see it? And then I'm going to find the what of these 10 observations. Wait. Watch again. I'm going to take 10 just random. I can hit the button. I took 10 random observations and I found the what of it. I found the mean of it. And if I keep doing this over and over and over again, I'll start to build up a theoretical what. Like it'll start to form a shape, and we might call that shape a what. So remember, I'm just taking 10 observations, and then I just find the what of those. I find the mean. There's another mean of it. And after a while, it looks like it's building a what? It looks like it's building a new what? A new distribution of what could happen if I take 10 observations. What's the shape of this distribution? What's the shape of this distribution? What's the shape of this distribution? It's normal too, right? And this is because the original distribution was normal. But what would happen if I did the following? Now my original distribution looks very, very what? My original distribution looks very, very what? You'd say, Brian, that's super duper what? Like, very skewed. Right to the high, left to the low. It's right skew. Right skewed. Nice job right there, Mackenzie, 100 points. It's right ugly. Right skewed. Emma, nice job right there. Oh my gosh. We're going to make that a Mubot quote, Emma. Oh, wait, Dad. Oh, no, Emma. I was going to make that a Mubot quote. It's gone. It's gone forever. We'll never see it again. I'm still going down here, and I'm going to take 10 observations, and I'm going to find the what of those 10 observations again. This is what you are seeing. This is the sample mean right here. And if we repeat this process, we will get a what of the distribution of the sample mean. Well, that's what we'll get. We're going to get multiple means. Tell me, what do you still see? I wish it was still there a little bit more. Let me redo the custom. I want to make it even more skewed because I want it to look even crazier. Here we go. Okay, there we go. Ridiculously skewed. I'm going to take 5. Okay. So every blue dot is the average of 5 black dots. Does this look normal, yes or no? Does this look normal, yes or no? If you tell me, that looks whack right there. Everybody says, I agree. No. What condition do you think we didn't pass? What condition do you think we did not pass when I did this example right here? It kind of had, well, Kai, a little, it's got some newness. It's a little bit bimodal, right? Looks like mountain ranges. I do agree. We didn't pass, as Avery says right there, the large enough n condition. Why do we care about these conditions? Why did we care about the conditions for proportions? Why do we care about the distribution of the sample mean conditions? Why do we care about these conditions? Why do these conditions matter? By not passing these conditions, we can see where the issue is. Why do these conditions matter? What's the whole point of these conditions? So that we can have the normal curve, so we can use a mean and standard deviation to talk about it. We can't use the mean and standard deviation for this curve. As Avery says, whack, we can't do it. So what might help make this curve more normal? And I want you to think about the name of the condition. What's the name of the condition again? The name of the condition is the what enough what? A larger sample size. More sample size. More sample size. Large enough n. So if n is larger, the curve of the distribution of the sample mean, not the original distribution, the curve of the sample mean will start to look more what? If n is larger, like if I go here to n of 25, and I'm literally averaging together 25 points, this will start to look more normal. And it might look normal, still a little bit askew. What do you think? Because that's super duper skewed. So maybe if the question said you have a very skewed distribution, you would say my n should probably be this large. How large would you say n should be if I had a very, very skewed distribution? This is a really good review of this condition. How large would n need to be? 100. And Leo's looking at the notes right there. Because the more skewed it is, the larger n needs to be. That's a good way of thinking about it. Like the more skewed it is, the larger n needs to be. Large fries right there. So tell me, do we pass the large enough n condition here with a sample size of 2? Yes or no in the chat right now. If you understand the condition, you should be able to tell. The question says the heights at UT are normally distributed. We're going to take the sample mean of 2. So do we pass this condition right here? The heights of UT students is normally distributed with 16 units mean and 5 standard deviation unit for the distribution that's normal. I don't know what that's in. It's in UT units. So I want you to put yes or no in the chat and explain why. So put a capital yes or no and then explain why we pass it. And we're doing pretty good on the poll right here. Good on the poll. So who can explain it? Because you got a 50-50 guess. If it says, do we pass? You'd be like, yes. And I'm like, oh, you're right. You're like, yeah, I have no idea why. So what do we need to think about? Look at the condition. And I think a lot of people are getting it right there. What do we need to think about if we're checking this condition? So what do you need to... Mackenzie, not 100 points. You're right. Priya, great answer. Priya, thank you for asking. Ask anytime you're lost right there. And Priya, Mackenzie's right there. And we're putting some emojis. Love it. So what Mackenzie and Leo also saw, and also Avery saw, is that the original distribution is what? So this is the way to do it. The original distribution is what? Say it with me. This is the way to do the large enough n. The original distribution is what? We're going to practice this. We'll do another one. The original distribution is what? It's normal. So the original distribution is normal. I need a sample size of at least what? Like if you have this is fine. I need a sample size of at least this amount. The original distribution is normal. I need a sample size of what? At least this. Like this or more. Original distribution is normal. I need a sample size of 1. Great job, Aaron, right there. So we only need 1. Is my sample size at least 1? Yes or no? Is my sample size right here? I hate that this is capital N, but is my sample size at least 1 right here? Yes or no? Is my sample size at least 1? Then we pass the condition and the distribution will be nearly normal. How about this though? I'm going to draw this and we're just going to call this skewed. My sample size is going to be 5. So first question is my distribution. Leo's got it already. Great job, Leo. So, because the more skewed it is, Leo. So my distribution is what? Kurtosis is sometimes called peakedness, but because it's got the kurtosis measure. Wikipedia has some good articles on kurtosis. Like, how do you know kurtosis? It's a measure of peakedness of sort of a distribution. So it's a statistical. Robin, if you are still here, if you want to put some notes on the statistic kurtosis, that'd be awesome. I always just call it peakedness, and then I read the Wikipedia article, and it's like often misunderstood as peakedness. I'll show you the Wikipedia article right after this, and you can see it shows different kurtosis of curves. I think 0 is the normal curve kurtosis, or maybe it's a uniform distribution. It deals with the shape of the distribution, peakedness of sort. Not according to Wikipedia though. So what this is right here, the first thing we check is the shape of the distribution. The distribution is skewed. Since the distribution is skewed, we need a sample size. Spam the chat with it. We need a sample size of what? Since the distribution is skewed, we need a sample size of at least this. Since the distribution is skewed, we need a sample size of at least this, 30. So now we say, do we have a sample size of 30? And let's go ahead and take a look. Did we take a sample size of 30? Yes or no, spam the chat. Oh, nice job right there. Over 30, please. Did we take a sample size of 30? Nope. So is this going to look normal or not normal? So normal or not? Just say normal or not. So the nearly normal or the large enough n condition states that if the distribution is skewed, we need a sample size of at least 30. We're not going to have it. So it's going to look, it's got some skew to it. It looks kind of, the central limit theorem is amazing, but it's still not normal enough. I should have made it even a little bit more skewed. We need a sample size of at least 30, and then it'll start to look more normal. This only goes to 25, but notice it looks a good bit more normal. Also, what is decreasing about this distribution? Last concept, kurtosis is referencing the peak, and I think of how squished or spread out around the peak is like a uniform distribution, and so I'll show that really quick because Wikipedia has a great thing. Thank you, Robin. 100 points, Robin, in the chat. Robin has her PhD, I believe, in statistics, so shout outs to Dr. Taylor right there. Correct me if I'm wrong, Robin. So I will always be asking some knowledge questions right there. Here's a really good picture on Wikipedia on what kurtosis is. Oh, nope, not in stats. Oh, ed psych. That's all. Oh, I knew that. We talked about psych because I got psych degrees too. W for the PhD right there. So here's the kurtosis. The normal curve has a kurtosis of 0. And look, it's peakedness. Come on, Wikipedia. That's peakedness. And then the when it gets, I know it's so pretty. So the kurtosis is a measure of peakedness of sorts. Wikipedia gets mad. Watch, if you type peakedness into here, it's like the sometimes seen characteristic of kurtosis as peakedness is in.
It doesn't matter.
Oh, we'll finish off the Canvas content here, and then we're gonna open the floor for questions. If you have a question, make sure we know. So the mean stays the same. The 10% condition, answer 1 or answer 2 right here. The 10% condition, answer 1 or answer 2. The 10% condition states that we need to sample no more than 10%, or we need to sample more than 10%. Great job, Arden, right there. 100 points, Arden. So once again, we covered those conditions. We should get that 100. And once again, I want to state, write down the questions as you're doing them. Make sure to practice these, and then don't just look at the question as its own thing. Remember, we did a huge review of sampling distributions right now, talking about the notation, talking about the conditions. Let's take a vote in the chat. Which chapter to do? I'm going to put let's put regression. We're going to do one more thing probably before the Kahoot. Decision trees. I'm going to put 2 more options. Probability. We already did chapter 13, and then sampling. So the vote is in the chat. We're heading back to the main screen. Canvas content about the tests fail. We might tomorrow. Well, Leo, we'll return back to that. Leo, thank you so much. I don't know which one that is exactly, but Leo, message me. I might give you a little advice or like kind of, I don't want to answer the question, but I might give some hints, especially I put it out in the videos to whatever we do if it goes to everyone. Then we try to do some reviewing of it. Take a vote. Yeah, thank you, Leo. Great work, Leo. Excellent work. Thank you so much, everyone, for being here. Really good practice. Probability's winning out right now. Whatever you want. We're going to try to do at least one more review of a chapter. Now, where can you go? Someone have MuBot tell us where can you go? Where can you go where everyone knows your name and you can study for the test? Well, not a literal place, but what site, if you have MuBot, tell us. What kind of probability questions can we expect? Ooh, well, regression's winning out. Because that quiz. At least one problem's are pretty tough. Great job, Troy. They're putting MuBot's going to put the link right there for the test 2 review. I would watch speed runs. I would do practice questions. There are practice test questions. There's with a key and everything. So check it out. Kaya right there helping out. Nice job, Kaya. Probability's winning out right now. Speaking of MuBot, lag. Was there lag? Oh, Troy knows. there wasn't actual lag, right? Darren, stop messing with the internet. Man, I spoke to him yesterday. I told him stop messing with our internet. JK. Darren. We're doing better, Leo. No lag. Good. I updated OBS. I power cycled the router and modem. I had to change. We're not using the graphics card for encoding. OBS updated and it got mad about the graphics card. The 2080 Ti is not doing my encoding. So, sad day. Looks like we're doing some probability and then we might do some regression afterwards. Okay, so stay tuned and tell people the Kahoot's coming up here. Let's go do some probability. Okay, so we are 1 hour in and it's time for probability. So chapter 10, 12, probability. The question would state it. Great question, Priya. Sad music. So the question would state, so it's no 3080 or 3090, but you know, thank you to Haslam College of Business for that, because I definitely didn't buy it. They have helped me out a ton. Probably, should we start easy or hard? Spam the chat with easy or hard now. Should we do the easy thing first? Do you want to jump right into a hard question? Because I can do the easier parts, the things we should memorize, or we could just do the hard. 3080, nice, Leo. Leo's saying just jump right into it. Kai's saying hard. Okay, let's do this. Yeah, looks like we're gonna do this. Let's do this. I got a split. We'll take a vote right here. I'm gonna write some stuff. So let's go easy peasy. Easy peasy or crazy hard. Okay, so take a vote. I'm gonna put some stuff right here. So what I'm putting right here is some notes you need to have memorized. And here's the thing, and I like to point this out. Here's what you need to memorize. This is on your formula sheet, and I can't tell you how many times I see people get this wrong. And I'm like, no. I'm like, I am sad. Some Waterloo sparkling grape. My soda's flat. My sparkling water's flat. Okay. What's the first line right here? And then we're gonna do a tough problem. We're gonna jump into the harder problems in a moment. What's this first line? What's the deal with it? As Jerry Seinfeld once said, "What's the deal with that first line?" I think that's the Seinfeld episode. It's the one where Kramer comes over and acts all wacky. What is that first line right here? Who knows what that first line is? What is that information telling us? It is the addition rule. Priya, 100 points right there. You're right. That's the addition rule. Now, this is the addition rule. And this is on your formula sheet. So we need to know what mutually exclusive means. The way I like to think of mutually exclusive, Fresca's awesome. Good Fresca's right there. And Leo's helping out right there. So mutually exclusive means the following. It also means disjoint. I like to think of concentric circles. And Robin, I need to post, Robin made an amazing handout. Sorry I didn't send it to my class yet. But it shows the concentric circles right here as we talk about when your parents bring you to the pet store and they phrase the question how, and you will get one of them. I don't know. Okay, you can be the kid who says, I'm not getting either. How do your parents talk to you when they go to the pet store with you? Exactly. And Robin's saying right there, addition rules when we need to see if they're occurring simultaneously. So how do your parents communicate to you at the pet store about the dog or cat you might be getting? When they say dog or cat, how do they communicate this option to you? What do your parents say? You can't have both. We can leave here without an animal, but you're not getting both. You can have a dog or cat or nothing. If you want both, you get nothing. Pick one. Pick one, or we don't have to get a pet today. Think about this. If you don't get a pet today, then you are not in the probability space where you got a dog or cat. So we can write this out as a table as the following, and even review a little bit of the probability rules, where we have the event of getting a dog, and we have the event of getting a cat, and we have the event of getting a bunny, and we have the event of getting nothing. And then the probability of said event is this right here. And for some reason you really like cats, and that. And then last but not least, what is the probability of the last thing in the sample space? This is the sample space right here. And what is the probability of the last thing in the sample space? The sum, and Kristen's reviewing the rules, the sum of the sample space must equal to 1. That is rule number 2. You don't got to know the order of them. First rule is all probabilities are contained between 0 and 1. Second rule is the sum of the sample space must equal to 1. The addition rule, and once again, the thing we need to check right here, if this is a valid probability space, all probabilities are contained between 0 and 1, and also the sum of probabilities adds up to 1. This is a valid sample space. I did not put bunnies up there, but we got to give shout outs. Independence, great job right there. It means the probabilities do not influence each other. Robin said, I would take down those notes. Robin's got in the chat. You can double click it or triple click, and you can just copy paste. So these are some great notes to have right here if you have them right there. I'm actually going to take right here from Robin and put them on our screen. And so we have them here for you to see, and they're here. Thank you so much, Robin. 100 points. And so let's take a look right here. The addition rule is as simple as it sounds. What is the probability you get a dog or cat? I think we showed the bunny at the start of the stream sometimes. What's the probability you get a dog or cat? What is the probability you get a dog or a cat? 80%. That's why it's called the addition rule. The dog or cat probability would just simply be adding up dog or cat, and then you have to make sure you know that these are what? Disjoint, i.e. mutually exclusive. Great job, Priya, right there, and everyone. Good practice. So we know that we simply just add it. I know. Well, thank you so much, Leo, right there. It's a bit early before the exam, so people come back and watch it, but that's all right. We're having a nice little get together right now, just relaxing. What now? This is a trick question. You ready? You ready? Let me state this. These are all disjoint events. What is the probability? I'll put it below it. What is the probability you get a dog and a cat? Ooh. Who knows this? This is like the practice test. These are all disjoint events. What's the probability you get a dog and a cat? SI review. Shout outs to Alyssa right there. And Priya's right. It's a trick question. The probability is 0. Because getting a dog depends on getting a cat. And that brings us to the second rule. And Robin was pointing out here in the second rule, if we're going to go here to the multiplication rule, if we are going to multiply, and you probably heard the word and right here, so you thought, aha, he's asking me to multiply because I heard the and. So right here, we have to check if the two events are what of each other. If we multiply, Leo, you are correct. If we multiply, you need to check that the two events are what of each other. Anytime you're about to multiply, and this is on your formula sheet, so really good check. And Leo's saying independent and dependent. I like it. And you can see it. It's in here. So you can see the and this and the independent. So you've got all the information presented to you right here on your formula sheet to remember and to practice with when you're doing problems. So when you think about this, good advice right there, Kristen. Everyone giving some good practice and stuff in the chat. When you think about this, think about what happens. We're talking about somebody like you who has a parent that says you can only get one pet. What's the probability you go home that night with a dog and a cat? Just tell me theoretically. Don't even think about the question. Don't even look at the numbers, Rock knows.
It doesn't matter.
Your parents say you're getting a dog or a cat, or you're getting neither. So just tell me from the question itself, what's the probability you get a dog and a cat tonight? So tell me right here. Does everyone just understand the idea of it? Like the idea, your parents say, we're going to the pet store, you're getting a dog, or you're getting a cat, or you're getting neither. You say, well, I want a dog and a cat. And they say, well, that's not happening. So we just figured it out. So we just figured it out. We understand it theoretically, and now we need to understand it mathematically. So what's going on with the mathematics? It turns out these probabilities all right here are very what on each other. These probabilities are very what with each other right here in this table. Every probability in this table is very, very what on each other. This is the mathematics understanding of it. Very dependent. Because if we know someone got a dog, then what's the probability they got a dog? If you know somebody got a dog, then what is the probability they got a dog? I know it sounds like a weird question, but let's say they got a dog. So what's the probability they got a dog? If you know somebody got a dog, what's the probability they got a dog? It'd be 100%. If you knew that, what would all the probabilities in the remaining portion of the table be? This is the mathematical understanding of it. If you knew someone got a dog, then they got it's a fact. Then the probability of them getting a dog is 100% because they got a dog. So Allison will be talking about that and reviewing that. This is a good practice differentiating the rules. And then I think people are pointing out every other probability would be 0. So if you actually, and this would be the proper way of using the multiplication rule right here, because we see the dependent probabilities now because the probabilities have changed because we know one event. So if you actually use the multiplication rule right here, you'd actually be multiplying what and what. So to properly use the multiplication rule, what would you be multiplying to properly use it? And you will see you can actually solve it mathematically correctly to show that it's impossible. So what would be the actual mathematics that you could use after you know the dependent probabilities? So you'd actually be solving what mathematically? Because everyone said 0 a moment ago. Exactly, Priya. Because we know they got a dog. It's impossible to get a cat, so it's impossible to get a dog and a cat. We don't expect you to have that deep of an understanding of it. What's the number one thing you should know? If you are multiplying two events, they must be what of each other? If you are multiplying two events, they must be what of each other? If you are multiplying two events, nice job, Mackenzie and Troy helping each other out, they must be independent. If you are multiplying two events, they must be independent. Let's do a check right here to see if you know what independence is, and then we're going to do the really hard question I mentioned. So what is independence? Okay. Let's say Brian drinks coffee, or we'll do event 1. E1, Brian drinks coffee. E2, Brian's brother Darren in North Carolina drinks coffee. E1, Brian drinks coffee. I'll do a new one for the third example. E2, Brian's roommate. There you go. A kid. That'll change in 2 weeks. Good change right there in 2 weeks. E1. I'll do this one. This is a classic one. It's 20 degrees to it's snowing today. Okay. I know Kai, right? Okay, so the first one right here, people are putting some Brian's. The first one right here, people are talking about already in the chat. Brian drinks coffee. Brian's brothers, Darren, drinks coffee. So this is the way to test independence. This is the way to test independence. The way to test independence is you ask this. I know Brian drank coffee today. Well, not student. She's resident. She's a veterinarian. So yeah, shout out to Sky right there. I know Brian drank coffee. Does that tell me anything, or does that make me think anything about Darren drinking coffee? What would you say to that? Like, I know Brian drank coffee today. Does that in any way change my opinion or belief about Darren drinking coffee? So I know Brian drank coffee today. No, it's like Rock knows.
It doesn't matter.
I don't think Darren, Darren drinks coffee this % of the time. Brian drinks coffee this % of the time. Brian drank coffee. It's going to tell us nothing about Darren drinking coffee. You could, unless you are secretly yeah, exactly. Maybe they're twins, they're telepathic. I need a little more info on this problem, Brian, here. But if you didn't know it, Chelsea and I do live together. She is my fiance. I thought it would be very important to make sure someone watching this video and doesn't know, Chelsea is lives with Brian. And drinks from same. We have a Ninja coffee machine now. It's all right. We had like a $40 Keurig that was just amazing. But she drinks from the same Ninja coffee machine. I'm not giving you shout outs to Ninja. I've already given you too much product placement in this video. Maybe well, she kind of does. We got cans in case we need it. But if our Ninja machine, think about this. Brian didn't drink coffee this morning, and I love me some coffee. So yeah, I was like, I went all out because our previous one broke after like 5 or 6 years. Not sponsored, hashtag. We're sponsored by Raid Shadow Legends. Does your coffee perform sick? I wish. But I never go to Starbucks. So that's a good way to save money. So I'll give you life advice over this in a moment. But this right here is a very, very what thing. This is very, very what? NordVPN. You watch some YouTube too, Carter, it sounds like. These are very what events. I'm trying to point to you what right here. This is very what? Dependent. And it doesn't mean if Brian drinks coffee, Chelsea will drink coffee. It doesn't mean if Brian doesn't drink coffee, Chelsea won't drink coffee. But if you know Brian didn't drink coffee, it might influence, like there might be reasons behind it. Oh yeah, we got our browser, we got our VPN. Yeah, Honey was big for a while. So it's probably still big or something. Good ideas to go out there and get all those. Last but not least, because we haven't done this once, this is a little bit different right here. Brian, got you too. No, Charles, not yet. It's 10 degrees outside today. It's snowing today. It's snow today. Okay, I think this is one of the easiest ones to know. Is this independent or dependent? Then we're gonna do a really hard problem to this. Is this independent? Oh, nice job, Robin. Explain if Chelsea makes a pot of coffee, it's going to increase the probability of Brian drinking coffee. Exactly. Oh, we have an independent-dependent split. Let's do independent vote, dependent vote. So take a moment in the chat and vote. And I want you to do the test in your head before answering. You ready? Here's the test. So here's the test. I can make the pot too. So here's the test. Are you ready? You say to yourself, it's 10 degrees outside today. Does that in any way influence my mind on whether or not it's snowing? I'm not saying you know it's snowing. I'm just saying you know it's 10 degrees, going to be 10 degrees today. Someone just says, this is going to be 10 degrees tomorrow. Does that in any way influence your mind on snow? What are your thoughts on this? Maria says yes. Maria, explain further. Now, if it's influencing your mind, what does that mean it's going to be? Like you would say, well, then the temperature and snowing are what on each other? So this is a good example. The temperature and what are what on each other? You might get additional information, but let's just say the temperature and the snow, good answers right there. The temperature and snow are what on each other? Like the probability of snow today, 10 degrees is pretty low, right? Depends, right? Like snow depends on the temperature? How about anyone want to take a guess of the probability of snow right here? Just drop a number in the chat and I'll show you. Look, you're about to see this live in real time. What do you think the probability of snow is? It's 10 degrees. Just throw me a number. It's 10 degrees. What's the probability of snow? Just show me a number. 40%. I like that. What's the probability of snow now? Oh my gosh. What's the probability of snow now, Avery? What's the probability? It's almost like the second probability is what on the temperature? It's almost like the second probability is what on the temperature? Say it with me. It's almost like it's dependent. Because the temperature would either increase or decrease the probability of snow. And that's what we're talking about the idea of dependence. There's additional variables outside the model that we're currently speaking of, like precipitation. You good answers, Charles. Lurking variables, chapter 7. And this has been, we'll do one more big question, and we might do a little more chapter. We didn't do a regression, so this will be great, because that's not in the Kahoot. Don't tell anybody. So here's your really super hard question. Are you ready? Who's ready? I need some I'm ready's in the chat. I need a little SpongeBob right there, a little dab in the chat. So I need some SpongeBob I'm ready's in the chat right here. Brian's going to write the problem here. Let's get serious. Calling a little hacker man. Here we go. You have Doctor Strange's time stone. And apparently that's a typo. It's time stone. You have the ability to take the Stat 201 test 5 times. Your studying allows you the probability of getting an A to be 30%. What is the probability you get an A at least once in one of these alternative realities right here? Check out new Doctor Strange coming out soon right here. Benedict Cumberbatch, Cumberland Street, Benedict Cumberland Avenue. So you have Doctor Strange's time stone. Stranger. Yeah, and yes, Doctor Strange. Dormammu. Ooh, I have come to bargain. Okay, so how are we going to get started on this? The first thing we're going to do, hopefully people understand the problem right here. Ooh, Kristen. We're throwing 1,000 points if Kristen got that right. We're putting a 5. Calvin, too. Holy mum. I'm going out on a limb, and I'm going to guess they're right. 1,000 points. Shout outs to Kristen and Kelvin. Lots of studying. And Parker. Sounds to me like people have been practicing. Let's see how they solved it. So get ready here, everyone, as we practice and solve this problem. The first thing we do when we get to a problem like this that looks like a lot of work is we write down the notation. So let's go ahead and take some notation down right here. The probability of getting an A is what? So I'm going to write probability of getting an A is what? Probability of getting an A is what? Hey, Clara, great to see you here. Yes. Good to see you, of course, Clara. 100 points, Clara. Thanks you for swinging by. Of course, Clara, great to see you. Probability of getting an A is 30%. What do you think I'll find immediately now that I know the probability of getting an A? Probability of getting an A is 30%. Immediately find this. The complement, which is what? So, sometimes I write it that way. We'll write not A. We're not doing math. We're doing statistics. Probability not A. Probability not A, yep. You either get an A or don't get an A. Those are complements. Those are disjoint events. They're also dependent. Disjoint events are dependent because getting an A depends on not getting an A. They're different concepts, but it is true that disjoint events are dependent. But they're different concepts. Don't think, oh, don't. Okay. So now we have to go here and we have to think about this. What would be the worst case scenario with your time stone? You can only use it 5 times because you're creating alternative timelines here. You don't want to mess up reality. What would be really bad? What would you not want to see? What would you not want to see? So what would you really not want to see? What would you really not want to see? Like, explain to me would be, you're just trying to get an A on the test. Exactly, Emily, great answers. You don't get an A at all. You've got here 5 times where you don't get an A. Does this make sense theoretically? And we'll write more math on this. Who understands this right here? This would be sad day for you. Where I played the sad day sound effect. So you don't get an A, you don't get an A, you don't get an A, you don't get an A. Would you agree with me? Theoretically speaking, there's only 2 things that could occur. You never get an A, or you get at least 1 A. Does this make sense theoretically? It is the case that you never get an A, or you get at least 1 A. Who understands that theoretically, just as a statement? You're going to do this thing where you take the test 5 times. You're either going to never get an A, or you get an A at least once. And this also wipes your mind so you can't learn from it. So each one is going to be independent. That's key. Your mind is wiped. Let's add that. Your mind is reset after each time travel. So each test is independent and also a random test. Okay. It's a weird question. I wanted to go weird, but we'd have to have key assumptions like that. So key assumption that there's independence right here, because the question could be undone by saying you learn from the test and thus the probability changes. But the probability each time you take the test is going to be consistent. We don't have nearly enough pop chart these days. Okay, so you either never get an A or you get an A at least once. Though one of those things must occur. Immediately right now, I'm going to change this a little more mathy. Well, first off, what does this add up to? Since this is everything that can occur, what does this add up to? What does this add up to? It is addition, and it adds up to 1. Because this is the set of all events. It is the sample space. It's everything that can occur. And Priya right there, great work. And we're going to add this. Does that make sense? Who's following along right here? Now we want to figure out never get an A. Never get an A is the easy one to figure out. Because if you never get an A, great job right there, Leo. I think, double check the math. I think you did it correctly, but did repunch it in the calculator, Leo. Repunch it in the calculator. Because I think that looks right. How could we re-express you don't get an A, and 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 you don't get an A? I think that many times. How could we re-express that? How could we re-express it? Just the first part. You don't get an A, and you don't get an A, and you don't get an A, and you don't get an A, you don't get an A. Because it's going to be this right here. Multiplication rule, right? And we're making it so it works that your mind is reset. So each trial is an independent trial. The question is some crazy sort of Marvel universe question. So now here we have this. We're going to re-express this just a little bit more as Troy, excuse me, Leo did. We go right here and do the following. And now we're just moments away. Let's do a little algebra, right? All we have to do now is take and just algebra this over to the other side. And that's the answer. And everyone's putting in the chat, great job. We're just going to copy paste Priya's answer right here. Priya, thank you. Priya, 100 points right there. Priya, great work. There you go. We're going to do format shift for the thing. There it is. And yes, there it is. We'll re-express it the way we have it written because we have the probability on that side. And there it is. That is the mathematics. And on a scale of 1 to 10, how hard did this question feel for people? These are some of the hardest ones. There's different formats of questions, different ones. But you'll notice this question, if you know how to write it down, some people can solve it very quickly. Kind of hard. It's right, Emily. Good answer, Emily. These questions, especially for those who answered it super quickly, how hard was it the first time solving it? Felt hard, exactly. Laura. Great, yeah. Hard at first. Clara, great answer right there, too. More points, Clara. 10 originally, but like a 3 once you get it figured out. Exactly. The key is to write it down, to think about you are looking at this or this. I do a lot of examples of these. We'll probably do some on test day. Not anymore since struggle with for like 30 minutes on the quiz. Exactly. And watch examples. There's the bus question, light bulb right there. So these get easier with practice. And I just get people who get to the test and they say, I got no idea. It's all right. Don't worry. This is a tougher test. And I'm not trying to scare anybody, but I think test 2 is the hardest test. So I want you to know this. If test 2, if you make a lower grade than what you were expecting to make, test 3, a lot of people, I had a student who feared they were going to fail the test, but they made an A on test 3 and they made a B. That student, Dave, I think I can say his first name. He sent me the happiest message. He came by my office like when he had graduated just to give me like, he was like, can I take a picture with you? And I was like, yeah. He's like, can I come over? I was like, sure. He's like, I just want a picture with you. But he made a B and he was just so excited by that. And so don't be nervous. My best advice to you is the following. Use note cards, practice, do example problems. And if the test doesn't go well, do every homework assignment, do every quiz. And thank you, Robin, right there, throwing some great advice. Doing the homework, doing the quiz, the visualizations is a great way to make sure your grade is kept as high as you can before the test. The tests are the toughest parts, but don't let that scare you. It is scary. The tests are the toughest part. Let that motivate you. And know that you can do well on this test. As I think it was Troy and Avery were pointing out, Avery, can they conquer these problems? Avery, can they conquer these problems? So to Troy and Avery and Leo and Kristen, everyone who's answered this question like this, can they conquer it? Tell them, we got this. Can they conquer it? Of course, I like that right there. Let's do a little bit of regression, and then we're going to come back here and do some KAHOOT. So tell people the KAHOOT's going to start here in about 20 minutes. You got this, Mackenzie. You got this. Just everything we can do to practice. We're going to keep a positive attitude. Let's go back to the main screen. Thank you so much, everybody. With practice, nothing is impossible. Famous group once said, anything is possible. Anything is possible. We got this. Yeah, and tell us if there's a rounding error. I'm always, if some little like a hundredth or something and our test doesn't have it, you can contact me and say, yeah, it's tough. Chapter 14 is tough. We'll be doing a lot of review of that tomorrow. Okay, so we're going to do some chapter regression. I couldn't remember the name of it. The KAHOOT, I think, does not have enough regression on it. Who can put it in the chat for 100 points right now? Where can you go, where everyone knows your name, and do some test 2 review? Who's got the chat right here for us? Because someone may be watching this video later and being like, oh, I'd really love to go to that review page. So where's the review page for us? Where is the review page? To be fair, we haven't covered chapter 14 yet. Yep. It's gonna be very similar to chapter 13. Review 2, everyone's spamming it right there. Was there lag? Mubot will tell us if there's lag. New thing Mubot can do with vols and volunteers and UT. A lot of new commands for Mubot as we're here just in the in-between moments. Okay. Let's do a little regression. And here we go. Back to the main screen. It has like a 3-minute cooldown, Leo. So anytime you want to just like throw the lag, I should have never put that in as a command because now people will say it just to have Mubot yell and say random things. He also knows random and randomness, I think, too. He's a good bot. Okay, we're doing chapter 7/8, regression. Who knows the conditions for regression? Let's start with regression conditions. Who knows regression conditions? As Mubot loves randomness. It's not condition 1 randomness today, though. So let's do some regression conditions. Who knows regression conditions to start us out right here? Who knows regression conditions? QQ, close. Maria, good close. QQ, straight enough. No outliers, plot doesn't thicken. QQ, straight enough. No outliers, plot doesn't thicken. QQ, straight enough. No outliers, plot doesn't thicken. Then I say to the class, what does that mean? And everyone says, I don't know. Well, QQ means what? I abbreviated QQ because it helps us also understand the condition. Ah, good review, right, Kristen? Good stuff. No heteroscedasticity. QQ means 2 quantitative variables. Now, I want to say this. If you don't have 2 quantitative variables, you are not doing regression. If you have like 2 categorical variables, you will get a mosaic plot. So this is not regression. So this is like the condition that has to be met. So if you are trying to figure out how much people spend on pets, is this good right here? Yes or no in the chat. For the first condition, QQ, which is 2 quantitative variables. If you're talking to someone, you might not say QQ. You might say, oh, you need 2 quantitative variables to do regression. So what do we meet this right here? And Priya's right, we do meet it. So we're asking, what is your yearly pet expense, which is the Y variable of interest, and the X being how many pets do you own? And you can see, ooh, maybe those other conditions are not so good. A little bit of a crazy relationship right here. So, but it is quantitative. But the second condition is, condition number 2 is straight enough. Now be careful, some people say straight and up, but it's straight enough, which is not the perfectly 100% straight relationship thing. It means that the relationship between Y and X is straight enough. So, oops, oh my. Is the relationship straight enough? Is it straight enough that a line generally goes through it? So what we want, and we always try to make this very clear on the test, is if you have something like this right here, is that straight enough, do you think? Is that straight enough? What does chat say? Is that straight enough? Is that pretty good? Yeah, that, and you might say, well, wait a minute. If I go and do this, woo, this is straight enough. Straight enough, it's good enough. It means like, yeah, pretty good. Yeah, it's pretty good. It's a little bit of a problem. We're going to make it definitely pretty clear. Generally, it's pretty good. Straight enough. Enough being the key word. But how about if we had something like this? And remember, we're doing a lot of questions because I can think of questions that are related to the test all the time. Is this straight enough right here? The answer is kind of obvious. No, it's not. Great answer, Emily, right there. Parabola. It needs to be some... Oh, coming up here in a moment. You're all right, Priya. Great answers. So if I were to tell you that r squared here is equal to 0, true or false, there is no association between x and y in this graphic. True or false, there is no association between x and y in this graphic. True or false? False. It's false because there's no linear association. That would be a true statement. The association here is parabolic. Exactly. It can't be, yes, good job, Clara and everyone. Go worry. I'm throwing 500 points for the people who got it wrong. Remember, we have a saying, we get it wrong in class to get it right on the test. So don't worry about getting it wrong. We're here to practice. If you get it wrong, you'll be like, oh yeah, it could have an R squared of 0, but that's only measuring the linear strength. So once again, it's only going to measure linear strength. There could be relationships that are not linear, that have some sort of an R's correlation. So an R squared can be found by doing R squared. Another question. Ooh, calculate. Here, wait. Oh, well, darn. Calculate R from this. You might already know where I'm going with this. Calculate R for this graphic. Okay. Calculate R for this graphic. I know, that's exactly it. If you miss this, you'll know it. Calculate R for this graphic. If you miss it, you'll be like, no, Priya, it would have to be perfect. And Priya, you're on the right track. And then who's seeing it? Some people are seeing it. Some people are seeing it. So if you want to take this, you should square root it. And then what do we do once we square root it? If you square root R squared, so you got R squared right here, and you're going to square root it. And then, people are seeing it now. You're going to look at the direction. So good practice, R squared, and you're turning into R. First disconnect of the night. Leo, lag. Darren messing with the internet on us. There's the R squared. Yes. Mm-hmm. And if it was -1, Priya, good answers, 100 points right there. First lag of the night, we can deal with just one. There can be only one lag. If it was -1, it would have to look like this. Does that make sense to everybody right here? If it's -1, all the points are directly on the line because then that line explains 100% of the variation. It would have a correlation of -1. So -1 is only possible for perfect negative correlation. So an R squared of -1 is perfect negative because it'd be from R of -1. Did I say an R squared of 1? This is an R squared of 1. I might have misspoke. R squared can only be between what and what values. Spam the chat with it. R squared can only be between what and what values. We're doing a lot of great review right here. R squared can only be between what and what values. R squared is contained in the interval. R squared is contained in the interval. You do this, maybe? I don't know. 0 to 1. Exactly. Because it's the amount of variation you explain in Y. So R squared can only be between 0 and 1. Great answers, because it's how much variation to explain. So speaking of, we'll interpret that here in a moment. But condition 3, QQ straight enough. Easy condition now. QQ straight enough. Help me out. QQ straight enough. When I see students miss this, we used to have them write out. No outliers. Emily, 100 points. No outliers. We're going to capitalize it. The condition is what it says. You just say no outliers. Okay, we're good. It's so simple. There should be no outliers. You just look, you ask if there's outliers. Outliers are things that go away from the bivariate trend. So if you have a bivariate trend, you would want the relationship. Here we'll do we'll do blue is good. You'd want it to follow this, and that is no outliers. Does this pass the third condition? And I'm trying to add a little confusion right here, but does this pass the third condition? Does that there pass the third condition? It does. The third condition is the no outliers condition. So the third condition is no outliers, and that's going to lead us into the fourth here in a moment. The third condition is the no outliers condition. Outliers, and I know there's a small differentiation here between when is it an outlier, when is it a plot thickening. This is going to be the fourth condition down here in a moment. Plot doesn't thicken, and it can also be bad. Doesn't pass the fourth. I'm a trickster today. Good Flash villain right there, played by Mark Hamill. The Joker and Luke Skywalker plot. Put in Justice League show. And live action with the Flash. The plot should have about the same thickness throughout it. Okay. And Robin, if you want, I could zoom you in, Robin. If you say zoom me in, Robin, I could get you zoomed in. You could say, hey, the students, if you want. So just let me know, Robin. You're like, hey, zoom me in. We could do it before the Kahoot real quick or whatever you like. And thank you, Robin, so much. Adding a bunch of great things right here. And Robin is saying, if we get to this fourth condition right here, the fourth condition is one we usually use a what to check. So we usually use on the fourth condition a residual plot. Discord. Oh, I know. I agree with Leo right there. If I could get everyone over there, I would. I do love some Discord. So right here, you notice. Well, we appreciate you being here. Everyone give shout outs to Robin doing such a great job. Robin putting some great notes in the chat, and just glad to have you here. So just shout outs to Robin. 100 points, Robin. Thank you so much. I also want to just like randomly, like, I don't know, just bring people in. It's a lot of fun. But right here you see this residual plot is, what is your primary concern with this residual plot? I'll draw the fourth condition in a moment. If you look at this residual plot, primary concern is going to be what? QQ straight enough, no outliers. And you got 2. It's no bueno, I agree. I got outlier, that point right there. You can go to rows and go to colors and make it red, and go to row and go to markers and make it a square point. And then you got a little bit of non-linearity too. Like this is the line, but we usually use the fourth. Plot thickening, I wouldn't love this as a test score here. Clara, great questions and answers. I wouldn't love this for a plot thickening. We've got really great ways in later classes to go into more ways to talk about the heteroskedasticity. The reason I say heteroskedastic is a plot is either heteroskedastic or it's what's skedastic. You don't have to know this word, but it's a fun word. A plot is either heteroskedastic or it's what's skedastic. And you can think about what it means and how it relates to the condition. So this plot over here is not heteroskedastic. And then we can think about what it means and how these are violated. Homoskedastic. So homoskedastic means same spread and heteroskedastic means different spread. This plot over here is thickening in some way. Now, you want the plot to have the what thickness throughout, which may help a better understanding of it. You want the plot to have the what thickness about throughout. You want your plot to have a homoskedastic relationship, which means the what thickness. And you don't have to know these words for the task, but they can help. So you want your plot to have the what thickness throughout. Consistent, and sometimes it's called equal variance or constant variance, same thickness. Plot doesn't thicken. Condition goes by many names, but the idea is that it has the same relative spread throughout the distribution. Because if we're going to use a metric like R squared, which talks about how much variation we explain, we don't want to have the model like doing super awesome in some spot where the R squared would be really strong. And then down here on the low side, the model's doing like super bad. So we want it to have the same consistent thickness so the measures of the model are consistent throughout the model. We go into more detail into later classes on this, but the easiest way to remember in 201 is plot doesn't thicken. So you want it to have the same thickness throughout. If I write that, will I get counted off for spelling? I don't think this may fill in the blanks. If you feel that if you feel the grading is ever not fair to you, just let me know. As people know, I look at all grades and I'll always, give it a second look. People have emailed me and said, hey, Brian, I should get some points back. And I say, nope. Or I say, yep. It all depends. Just let me know your thoughts. But here's an important thing. And let's take a note. We did note the regression, right? This is the last thing before the Kahoot. Interpretations. So let's do some interpretations. Who's ready? Dust off that material in your mind right here. Let's get ready for some interpretations. Interpretations big on this test. Ooh, Adam. Yeah, Adam, you're 324.74, right? Oh, 475 right now, Adam. Adam is throwing you some advice right there saying you got to know those interpretations. Adam, 100 points of random. Adam swings by. Let's do this. Let's do high school GPA. Hopefully it's not too small of a coefficient. Okay, let's look at work. Be interesting. Oh my gosh. Adam, what do you think the coefficient of work is in this model? Does anyone have a guess of the coefficient of work? It's probably going to be close to something. I can see it automatically. Coefficient of work is going to be close to, as Adam might say, the naive model. 320, 475 knowledge right here, 474 knowledge. Probably coefficient close to 0. Yeah, look at that. Coefficient close to 0. Great job, Kaya. Yep. Coefficient close to 0, so that's not going to be fun to interpret. That's no fun. That's not a fun model. Want something better? How long have you ever stayed awake? Let's see if that impacts your GPA. Not like cause and effect impact. Yeah, Kaya! You got... Yeah! Great work. You're like a flat line would go through that. Ooh, another... Okay, we might be able to work with this. Let me give one more try. This is the problem with like doing your own examples. Is sometimes you get something you like, sometimes you get something. Wait, you know what we can do? Watch this. Run all the regressions. I forget I've got tricks up my bag because let's just take right here and do this. Boom. Okay, cool. This we don't use that one. Ooh. Oh, age. Well, I've done age. Oh. Fit line. Okay, here we go. That's y and x with the y and x. Text in class. Oh my gosh. Oh, the coefficient's very small. Is there an actual lag? I hope not. I think people are just having fun. Last try right here because we need to get work done. I'm trying to do ones we haven't done. How much you work? Last try as Brian tries to find a new example on the fly and is failing miserably. That's beautiful. Nothing like an identifier being used. Don't do that. Oh, that one was real? What? Wait, where's the... Oh, age, of course. Of course, ages. Okay, we might use age. Ooh, wait. Yeah. Ooh, ooh, ooh. This is not fun. Okay, so this one has problems. That's so weird line fits like that. Okay, so let me grab this output. 2 seconds. Yeah, a lot of crazy regressions. But let's grab this output right here. Let's bring it over and interpret it. We found one finally we can use. It's kind of sad. You'll find out why in a moment. Okay, so where is... Let me get the intercept. Okay. So get ready. What 2 values do you think we are going to interpret? Or we could do 3. Let's do 3 values. What 3 values should you know how to interpret from this output? This is review. We're going to be doing Kahoot here in about 15 minutes. So what 3 values do you think you should know how to interpret? Great job right there, Avery, saying B1 and B0 are beta 1 and beta 0. Rather, the estimates are B1 and B0. So Avery is saying pretty much, well, not the variance, the slope, the intercept. So Avery's pointing to some values right here. R squared, and that's the other one. Great job, everyone. Good practice. So let's go right here. Robin saying, no, those were like, I'm sorry. Sudden link, why? And let's point to where these things are at. That's not part of the intercept. And last but not least, we have right here this. Okay. Oh, that's fun. Okay. It's kind of it's variation explained. Variance, it's a measure of the reduction of sums of squared error from the naive model, from which is the mean of y. So it's kind of, and that's why things like the root mean squared error might be a better measure of variance, the typical size of the residual. There's things we don't talk about in our class, like we don't know about the root mean squared error, which is the typical miss the model makes. You don't need to know that. The mean of the y, things right there. I've highlighted everything you would need to know about this. Ratio of variances, yeah, the ratio of the reduction over the sums of squares from the naive. So it's a ratio of variances. So with this, the sums of squared errors, rather. But the good news is we don't have to go in that much detail. And as Troy is saying there, B0 is the intercept. That is correct. Let's label our output right here. This value right here is the intercept of B0, and that's an estimate of the intercept. Capital B is often referred to as beta, which is true intercept, which we don't really know. We have estimates of these because these are created from a sample. And down here, we have B1, and these values are also right here, B0 and B1 respectively, not 1B. And so with this right here, how would you, and I want you to try, I'll tell you if you get the points, we're going to throw out some big 500 points. Who could interpret the intercept right here? And I would approve it right now. Get that Brian stamp of approval. Get that. Who right here has an interpretation of the intercept? Who has an interpretation of the intercept? Who has an interpretation of the intercept? When hours of sleep is equal to 0, we expect the number of weekly hours worked to be around 17.89. Is that logical or not illogical? Avery, great answer. Here, I'm going to do more chill music than that. Avery, great answer. Is that logical or illogical? And let's put in our, I'm going to write this out in a general format as you look at Avery's answer. So Avery wrote, oh, that's a bummer. I can't do that. So Avery wrote, when hours of work is equal to 0, we expect, it's sleep, right? Ooh, wait a minute. I have an issue here. Oh, I think Avery might have done it. Let me see. When hours of sleep is equal to 0. Good. When hours of sleep is equal to 0, we expect weekly hours of work to be 17.89 on average. It rounds up. It kind of makes no sense. Why does it make no sense? When hours of sleep is equal to 0, we expect weekly hours of work to be 17.90 on average. And the blank formatting of this is when x is equal to 0, we expect y to equal b0 on average. This is the blank formatting right here, which we are filling in. And make sure to know your variables. People need to sleep. Do get some sleep. Try to get 7-8 hours. Sleep. I tell you this much. Times in my life I was sleeping 4 or 5 hours a night. My body was not happy with that. Get some good sleep. Your body, your mind will work better. Your body will work better. I've worked overnight shifts before with no sleep. It can happen. And it's saying like a long run period. Avery makes a good point. So you might add that in. Is it talking about an average or like a single day? It says hours of sleep nightly. Oh yeah, so it's like an average, I would think, right? So Kaya right there, another 100 points. Kaya, great, because that's more wait, so Kaya says, let me write with Kaya. Yeah, it seems not good, right? So I think this is more of an average thing. It's like how many hours of sleep a night do you get like nightly? Not one night. It's like on average. So when hours of sleep nightly, so like I would say illogical because people need to sleep. So I would comment if logical or not. If it's logical, you don't really need to add that. I said they could be nocturnal. Oh, they could be nocturnal. Oh. Ooh, we'd probably have to give points for that, right, Robin? Like, was the question only counting sleep during the nighttime? Oh, I didn't see that, Kai. Another 100 points. If someone said that and then said, though, it's logical, maybe we're just talking about hours of sleep during the night. Maybe they're working the night shift, and so they're sleeping during the day, so their hours of sleep. I know, right? The things we don't think about when writing questions, and then we're like, I guess maybe it's logical if you think we're only taking the night sleep. But I think it means night being between Kaya moving different as per usual. I love it. I love it. And so now we need to go here and interpret the what. What should we interpret next? Someone named something we should interpret up here. We just did the intercept, which is B0. Here we'll color code that a little bit. What else should we interpret right here? So this was the intercept interpretation. This was intercept. We'll color code it to the other one. Let's do some slope. So how are we going to interpret the slope right here? So we'll do intercept. How are we going to do the slope? Who has my slope interpretation? See if you can do it now. Pause the video if you're in the future. And we've got the values highlighted on here for the estimate of the slope. So how would we interpret the slope coefficient right here? It's highlighted in the equation up above. For each 1 unit increase in hours of sleep, we expect the hours of work to decrease by around. Great job, Avery. Rockstar right there. We're going to throw some more points here at the end, but Avery, great job. I'm literally going to copy paste what Avery wrote in the chat. So look at that. Makes my life easy. And then we can just go to copy format. So this is the slope interpretation. So what you want to do is put these on note cards, practice doing this. And let's see, the slope is negative. Now make sure to do this. So Emily, 100 points on the test. And this is good news, Emily. On the test, that might get like 1 out of 3 points or something. So check out this interpretation right here. And then when you get to test, be like, wait a minute, I got to write the full sentence right here. So this is good practice right here. Here we go. For each 1 unit increase in what? For each 1 unit increase, what do you think I'm going to sub in right here? In what? What do you think I'm going to change this to? For each 1 unit, I'm writing the blank interpretation now. For each 1 unit increase in what? For each 1 unit increase in, but I'm doing the blank version, Avery, right here. I'm doing like the X. For each 1 unit increase in whatever X is, because up here it's this. So you can see, people are seeing it right there. So now we're just writing like a blank version so we could fill it in like we have up here. For each 1 unit increase in X, we expect, and then what is this right here? So what is this going to change to? For each 1 unit increase in X. Oh, I'll show it again here in a second, Troy. Y. And now here's the problem. Don't worry, it's not a problem. But I'm going to put increase slash decrease because the slope could be what or what. And this is the coefficient of the slope right here. I'm putting increase or decrease, which sometimes I forget when I do it in class. Because the slope could be what? This is written stuff, Leo. That's why we're practicing right here. This is written. So we definitely tell everyone there's written interpretations on the test. I would know how to interpret R squared for decision trees also. I know how to interpret R squared for regression. There'll be confidence interval interpretations on the final. But it could be positive or negative, so we should acknowledge that. And this is our blank interpretation. So check out previous videos, watch previous lectures. I think I've got them marked. So we're going to ask Avery right here. Avery, what did you do? Because you've been acing these interpretations. Avery, what was your plan of attack for this? Avery, how have you gotten so good to where if these are your answers on the test, Avery, you would be getting full credit. So Avery, what has been your plan of attack and what did you do to ace these? So and we do grade them by hand. Great answer questions right there, Leo. So Avery's going to tell us their plan of attack right here as we do the last, which is the R squared. So what is the R squared interpretation right here? Spill your secret. The little different part. Sorry, I'm literally X and Y. This is the Y, and that's the X down here. So what is the R squared interpretation? Who has our R squared? The information is on the screen for you right here. No blanks on the formula sheet. Carson, good question. The blank versions are not on the formula sheet. I'd put them on note cards. I'd label your stuff in your output, and I'd use note cards. You can't use note cards on the test, but note cards are really great to practice this. Who's got the R squared interpretation right here? And then we'll do the blank interpretation. Who's got your R squared interpretation on this? So take a look at the output on the screen. We're doing Kahoot right after this. Thank you, everyone. I know it's a late evening. Great job, Troy and Avery. And look at those answers almost simultaneously. We're throwing a big 1,000 points for all this practice right here. I know we've gone crazy tonight with all these points, but that's what we do right here. 2.79% of the variation in weekly hours work is explained by the variation in hours slept nightly. So we're going to take this interpretation right here and Command Shift. Here we go. And let's go take a look at this. Here we go. So the way you interpret R squared is, we'll copy it one more time, blank percent, which is the R squared. So make sure to do what to R squared. You always do what to R squared when interpreting it. I've seen this mistake. Your R squared, and I guess we could write that right here. Your R squared should be what? Always take your R squared and do what to it? R squared what? Priya, great job. Turn it, times it by 100. Does that make sense? So you're going to take your R squared, times it by 100, and blank percent of the variation in what? What are we trying to understand? What variable are we trying to understand right here? What variable are we trying to understand? Think of just the name of the variable, one letter. What's the variable we're trying to understand? The what variable? The Y variable of interest. That's the Y variable. And then when you say is explained by the variation in this. So when you think about R squared, it's blank percent of the variation Y is explained by the variation X, i.e. X does the explaining of it. So when you think about your explanatory variable, it's in great job right there. Laura and Priya and Clara, excellent work. The blank percent of the variation Y is explained by the variation X. Would you still the slope interpretation and the R square interpretation? Yeah. Let me do it. Carson, thank you. 100 points, Carson. Keep asking those questions. Here, I'll show multiple different screens of this. Let me leave the screen, and I'm going to highlight it here. Put them on note cards. There we go. This is not a typo. Ignore all. Okay. There's this screen right here, so you can screenshot it. Also, try typing it out yourself or writing it down. Best ways to do it, say it out loud. If you want Brian's advice on studying, we learn things different ways. If you write it, if you say it, if you type it, those are different ways that your mind activates when doing things. Also, explaining it to someone else. Maybe ask your friend, hey, interpret R squared in this output. Maybe pull up one of the ones from the review and be like, can you interpret that R squared? And see if they can do it and be like, and they're like, then see if you can do it. And maybe even have the answer right here to see if you can just like do it immediately. So that's a really good way if you quiz your friends, if you practice, and have them say it, because then their mind has to activate a little bit differently. Or say, hey, could you write down on this sheet of paper and I'll see if you get it right. Let's do a quick test. It's 20 seconds. You got this. The more you train your brain differently on it, it's literally like, does anyone else here work out? I need to start working out again. But you don't do the same exercise a billion times. You need to be doing different. I don't even know how to lift weights like this. Is that how you lift weights? You do it somehow. But you have to do different ways of working weights because your muscles are going to kind of shift in the ways that they kind of get used to the weights. So mix up your exercises on the way you learn things. Try, saying it, try writing it, try having a friend explain it, try explaining it to a friend, and then you're working your mind in different ways to help the understanding. I don't work out either. Don't worry about it, Laura right there. 100 points not working out. I don't got time these days. I just go on Pokemon walks. It's like, hey, Avery, don't skip leg day there. Let's go back to the main screen. Here we go. Good answers on the Y's and the X with decision trees. Well, tell everybody it is time now. Who knows what time it is in the chat? It is time. I worked out. Nice job. Good stuff right there. I guess I got to work out. I caught some Pokemon. Is that a workout? I showed Mudkip. What's up? Caught all the Mudkips. KAHOOT. Oh, hey. Troy's putting actual time in the chat. Actual time in the chat. KAHOOT. KAHOOT.it. Logging in right here. Can we KAHOOT woot? Woot. I don't know how to KAHOOT woot. We got Puppet Shark. And we got Tiny Puppet Shark. You didn't even know there was Tiny Puppet Shark, did you? A student said, there's Tiny Brian. Is there Tiny Puppet Shark? And I said, yes, there will be. So thank you to everyone who comes up with ideas and, things. I shouldn't press random buttons. Things can happen. Puppet Shark has a baby. Let me get the review up. Love me a late Kahoot. Nice stuff. And thank you everyone who's been here this whole time. Okay, got the Kahoot almost up. Black and white. Tiny Mew. Oh, there's no Tiny Mew bot. Laura, remind me via email. There's no Tiny Mew bot.
Mewbot was beatboxing. Thank you for everyone. I can be Tiny Mewbot though. 1 second, and then we'll start Kahoot. Where am I, Brian? Where is Mewbot? Mewbots. There we go. Mewbot. Okay, there we go. Brian, don't mess with my voice like that again. Okay. Okay, taking the dog out. Classic mode of Kahoot right here. Classic mode. Loading game pin. Mewbot mini-me. Oh, it's the music. Do you hear it? Mewbot will beatbox to it. You know what this means. Everyone get ready. We gotta put the real music on though. Disco music only. Here we go, everyone. Time to Kahoot. Let's do this.
I shouldn't talk like Mewbot. Here we go. Let's over to Kahoot. Let's do this. Okay, everyone, the Kahoot code is on the screen. Make sure to click in. Got the timestamp on Kahoot. Oh, it's the disco music. It's always the disco music here. Kahoot disco music's the number one way. Do we have, was it Grey Wolf last time? 686-263. People logging in. Got all the people logging in. We will review each question. Can we get 50? We will throw 100 points for how many people, like 20 means 200, 30 means 300. Can we get at least 100 tonight? Maybe I should like message in the, let me go put it in the stat 201. Got 56 watching right now, it looks like. I'm going to mention in the Discord. 201. Let me message stat 201. Kahoot is live. There we go. We got 400 points on the line. We're going to wait another 2 minutes or so. We'll see if we get a bump in the numbers. The amount of people we have watching pretty much limits the amount that we could have joined. So we got 50 watching, we're probably about 50 playing. Snowy Panda is going to show out. You got this, Snowy Panda. Can we get 50? Let me get the points ready to go. Points, add, plus viewers. You know what? I made my points buttons, and then I keep like upping my points. We got 500 so far. We'll put on a 2-minute timer, and then we'll start in 2 minutes. So if you want to grab a drink, a water, some cheese, some crackers, some pizza. I don't know what you got laying around right now. Some Swiss cake rolls. What is your favorite snack food? Put your favorite snack food in the chat right now. Do not let Brian around Swiss cake rolls. There will be no Swiss cake rolls if Brian is around Swiss cake rolls. Those things are dangerous. It's like you eat one Swiss cake roll, they're gone. Dill pickle dip, that sounds good. Pringles. Seaweed? Ooh, seaweed's some good stuff. Oatmeal. Oh yeah, yeah, those are so good too. Cheez-Its. So good. Veggie straws. Ooh, I do like some. That's in like the yellow bag, right? The egg. Chocolate strawberries. Oh man, I wish I had that as a snack. The tears of my exams. Charles is just destroying exams. Cheez-Its. Cheez-Its always good. Pickles. Goldfish. Pimento cheese and pretzels. Zen. What is Zen? Takis. Takis is some good stuff. Everyone's like having hot Takis these days. Chocolate pretzels are really good. What is a cosmic brownie? What is that? Those little frozen chocolate fruits from Target. Get those? Okay, cool. Next time I'm at Target, I'll have to get those. Chocolate chip cookies. Ooh. Especially you put them in like the microwave. I have Quest bars. Quest has some good protein bars, and I'll put them in the microwaves. Nice little snack. I've got mint chocolate chip and cookie dough. You don't know what I don't know what a cosmic brownie is. Oh wait, is that the white? No, I know what it is. The cosmic brownie is the brownie with the stars on it. I'm saying Swiss cake rolls. I'm still going Swiss cake rolls. Let's see. We're settling the debate. You decide. Don't just go with me. Cosmic brownies, Swiss cake rolls. You can only pick one. There can be only one. The debate's gonna be settled. Ooh, zebra cakes are good too. I'll take a zebra cake over a cosmic brownie. Sorry, cosmic brownie. We'll find out who wins right here. Michelle's going with some cosmic brownies. So I'll tell you, Swiss cake roll. There's a Boston cream one. Oh, my Swiss cake rolls are getting destroyed. Well, that's it, everybody. Class is over. See ya. Good night, everyone. Bye. Kahoot over. Check DM on Discord. Did you send me a picture of it? We're gonna start here in literally a second. Oh yeah. I'm putting a thumbs down on this. I'm giving thumbs down. All right. Oreos. I could go some Oreos. I'm surprised no one left. I did that one time and people left. Okay. Everyone, give me a countdown here. Start a timer. Let's start that timer and get ready to go here. Who's ready to go? Who's ready in the chat? I need a timer. Brian's Swiss cake rolls are losing out. Start that timer. 5, 4, 3, 2, 1. Let's go. Here we go. Kahoot time. Let's do this, everyone. First question of the Kahoot is: two events that can be easily added together must be what of each other? Two events that can be easily added together must be what of each other? People are answering right away. Now, when you do this, you are doing what is called the addition rule. And please, if you didn't see our review earlier, look at the formula sheet. look at the formula sheet. If you were to get a question like this on the test, go to your formula sheet and be like, okay. So we're probably going to look at the formula sheet here in a second because the formula sheet has a lot of good hints. Ah, Allison, 100 points, noticing maybe there's more than one answer. I do want to point this out. What percent of people does it look like got the answer correct? Please take a note of this. Oh, this is Kahoot music, Robin. Good question. It sounds like Jackbox music or something. It's Kahoot music, so we don't get copyright claimed. It's their music. It's a 50-50. Now, this is why I ask questions like this. Let's go to the formula sheet, and what do you notice right here? What rule are we looking at right here? I want you to look at your formula sheet and know how to use it on the test. And we had a 50-50 on this. What are we looking at right there? What is that up there? What are those? That's the addition rule. And huge shout outs. I'm trying to think, was it Lauren or someone said, maybe there's two answers because mutually exclusive can also be what? Mutually exclusive can also be what? Avery, that is correct. Mutually exclusive because it's like you have two circles. These circles right now, these are circles, they what each other. Like in the space they are in, think of that word up there. These circles what each other. There's two, they're mutual. They what each other. These circles I'm showing you, they what each other. They are currently whatting each other. They are currently whatting each other. These circles, my hands are forming circles. They what each other right now. Versus this. They might hate each other, but they exclude each other. This is mutually exclusive. This is not mutually exclusive. This is disjoint. This is when they share a joint. Does that make sense to everybody if we think about it that way? Like, here's two circles. You can see the circles. And it's hard because I'm mirror image, so I keep moving my hands the wrong way. They don't. So mutually exclusive would not be sharing any space with each other. We did some examples earlier tonight, so if you want some review on this, go to the pet store problem right here where we have either you're getting a dog or a cat. You can't get both. So we did a pet store example earlier. So we said you're either getting a dog or a cat. You're not getting both. So in this example right here, these things could be what of each other. This was our example from earlier tonight. If you're getting a dog or cat, you're not getting both. These probabilities could be what of each other in this table. These are all disjoint events. So you can what these probabilities. Your parents say you're getting a dog, or you're getting a cat, or you're getting a bunny, or you're getting nothing. And now do remember those other terms, some of them are being mentioned, are other concepts, which we will get into. So remember, disjoint just means that if one happens, the other cannot happen. As in, if you get a dog, you're also not getting a cat. But where can Becca go to find the exam review sheet right here? People put in the chat for another 100 points. Where can people go to find the exam review sheet? First person, I'm going to put it out here. Where can Becca go? That is correct, Leo, but throw the MuBot link in the chat, which will bring us right to it. We have here review 2, and review 2 should be put in the chat here in a moment. Thank you, Lauren, everybody. So check out this link right here. MuBot is putting in the chat right here, Laura. Becca said. And Becca, right here, you want to go to the formula sheet. MuBot put the link in the chat right there. No worries, Leo. MuBot will send us right to them. And don't put review 3 in the chat, but MuBot knows of that also. So that way we can go right to the link. So great questions, Becca. Becca, another 100 points. Thank you for asking. Let's hop back in. No, don't worry. If you get something wrong, that means you're practicing for the test. If you ace this Kahoot, maybe you shouldn't have been here. I'm not saying you shouldn't be, but the more you get wrong, the more you're learning. So get ready, everyone. Keep staying here. Keep practicing. We got Prairie Bobcat here, Prairie Bobcat, and we got Dr. Lizard. Dr. Lizard, man, I don't know if I trust a lizard to be my doctor, but Rockstar Finch, you can be Rockstar. Polite Rooster, thank you for being here, Polite Rooster, and Clever Yak. Here we go with the next question. Here it comes. Two events that have no influence on the probability of each other are said to be what? Two events that have no probability. Norman Osborn. Good stuff right there. Some Spider-Man. Dr. Lizard is a dope name. I think it's in the BTS song. They talk about dope. And so great work right there. So we talked about this earlier. I'm something of a scientist myself. Two events that have no probability, do not influence the probability of each other are said to be independent. Can anyone give me an independent, like this and this? What are two things you could tell me that are independent of each other? Like maybe the Patriots are playing Tampa Bay in the Super Bowl. And so would you say the Patriots winning is independent of Tampa Bay winning? No, those sound very dependent. Like if one wins, the other can't win. So what are some examples of independent events? What are good, Nicholas? What are some examples of independent events? Like what would be this and this? Like try to come up with your own example to make sure you understand it. Brian drinking coffee and Darren drinking coffee. That's an example. 100 points right there. Norman Osborn making us lizards and independent of Batman hitting theaters. Maybe. Is Norman Osborn trying to make us lizards? I thought that was Dr. Connors. Kurt Connors, I think. He tries to make us lizards. But you could say what happens as long as there's no crossover. What happens with Batman is independent of what happens with Spider-Man. Why is what's happening with Batman independent? Who knows? A little bit of nerdy stuff right here. Who knows why what happens with Batman in his universe is independent of what happens with Spider-Man? Aaron. Because they're in different universes. Batman is a DC character and Spider-Man is a Marvel character. So something happening to Batman would be independent of something happening to Spider-Man. Kirk Connors is the lizard. That is correct. So, like, let's say, I'm trying to think of, I don't know. We'll think of more examples. They're in different universes. That is correct. Do you think, think about this. The probability the Bruins win, if anyone knows who the Bruins is, and the probability the Braves win. Do you think the Bruins winning their game would in any way influence the Braves winning their game? So there's another example, and I'll explain why that works. Carson, send me an email and we'll take a look at that. Then I'll send it to you via email too if you can't get it. So we have the Bruins winning and the Braves winning. Why would those be independent? And Troy's pointing it out. The Bruins, if you didn't know it, are a hockey team, and the Braves are Major League Baseball. So a hockey team winning is probably independent of a baseball team winning. Does that make sense right there? So that's a sports example. I'm not the biggest sports person, even though I got my Vol for Life on today. But some comics and sports examples of independent things right there. Was the Bruins? That's awesome, Kristen, right there. So who's in the lead? Is it still Dr. Lizard? It is Dr. Lizard. I mean, of course. If they got their PhD in their... I'm not going to remove them. Here we go with the next question. Let's do it. Question 3 is, to multiply the probability of A and B, the two events must be what? Go to the formula sheet. Go to the formula sheet. Go to the formula sheet. This is a review. The code is down here, Benjamin, right there in the bottom right corner. Check it out. To multiply the probability of two events, the two events must be what of each other? To multiply the two events. This is a review right here. This is a review. So, pretty good work, pretty good work. Where do people see it? Let's go to the formula sheet. Once again, here it is right here. It should click. The formula sheet button doesn't click, but click the button for it. Where should I look? I could copy it, bring it over here to a screen, and then we'll ask like a region. What area should I look in? I'll disappear. Should I look in area 1, 2, 3, or 4? The question said to random lag is what we got. To multiply two events, they must be what of each other? And Fran is right, and Kai is right there. Thank you for everyone who puts up with our lag. I've looked into it, and it might literally be our DSL internet provider, Suddenlink. We love you, Suddenlink. But yeah, it might be nothing I can do till we get back to Knoxville and I get better internet. Because boom, right there. No worries, Carson. Great work, Carson. To multiply two events, they must be independent of each other. Great work. Yeah, Knoxville internet is probably beating out College Station Suddenlink internet. It's so your DSL internet provider can literally just like knock you down for a moment. They'll literally go. Thank you, Charles. Don't literally do anything. Prairie Bobcat. Whoa, shake up of the leaderboard. So, yeah, I know, Kristen, that's an issue too. So maybe, I don't know. We'll figure out some solution. I'll probably be talking to Haslam to say, hey, look, wherever I'm at in Knoxville, we need to make sure I got awesome internet. So with this right here, you'll notice that the leaderboard is shaking up, but do remember, and I feel bad, people will leave by the end of this Kahoot. Don't worry if you're not acing this. This is time to learn. So let's do the next question. Prairie Bobcat, Rockstar Finch, Polite Rooster, great job, Smart Ferret, and Amazon Jaguar. Let's do this. Here we go. The probability of a gross jelly bean is 25%. If you eat 3 jelly beans, what's the probability that they're all good? So grab your calculator real quick right here. We're trying to find the probability that they're all good. You know the probability of a gross jelly bean. So first thing you want to do is figure out the probability of a good jelly bean. Who can put in the chat right now the probability of a jelly bean being good? Who can put the probability of a jelly bean being good? The answer to the last one was independent, Becca. Good question, Becca. It was independent. It'll show a check mark on the answer. The probability of a jelly bean being good is 75%. So put those jelly beans in your hand. Eat the first jelly bean. How was that first jelly bean? How was that first jelly bean? How was it? The first one was what? How was it? No, it wasn't, Luke. It was good. And the second one was what? Good. And the third one was good. So what's the probability the first is good? Charles knows some Bean Boozled right there. First is good, and the second is good, and the third is good. What was the probability of that? You're eating some Bean Boozled. And the first is good, and the second is good, and the third is good. I should have put Bean Boozled as the picture. Who can write the probability in the chat? Probability of a good jelly bean is 75%. So what's probably the first is good, and the second is good, and the third is good? We'll see what people in the chat. The mathematical probability is probably this one. Yeah, it is. Who knows? Who can show what we did mathematically right here? So we have the probability. Great job, Clara, right there. Great work. We don't have to subtract from 1, though. And so that's, you have to be careful, though, because if you subtract from 1, then you would have at least 1 bad jelly bean. Maybe questions to come in a moment. So the question asked or said the probability of a gross jelly bean, we'll say not good, is 25%. The probability of a good jelly bean is 75%. I used to bring in Bean Boozled for the probability today. So I'd figure out like a kind of press your luck thing. So it was fun. I do different in-person examples than I can do online, obviously. But we want to figure out the probability of good and good and good. So the probability would be 0.75 times 0.75. Who follows this example right here? 350. Who follows this example right here? Who follows this example? So this is the probability the first is good. So why can we multiply these? Rock knows about the jelly beans. Each jelly bean would say, what about the last one being good? Because if the first was good, then the second one,
It doesn't matter.
it's not going to change the probability. Annabelle. Oh, thank you. We have a lot of different fun in person. We do different examples. I jump on tables. I'm excited. I've got a big plan for my first lecture in person again. We tear up and get sad. But I got some fun. I got this big crazy plan. Well, these are not mutually exclusive. But good and bad are mutually exclusive. But the multiplying of probabilities right here is capable because each jelly bean is what of the previous jelly bean. The multiplying of the probabilities of jelly beans is only possible because each jelly bean... Kale's got the answer already, so repeat the answer. The multiplying of the probabilities, and Kaya, great work right there, is only possible because the first jelly bean being good is independent of the next one. Like, think about this. If the first jelly bean is bad, will that in any way change the probability of the second jelly bean being good or bad? Does that make sense? The first jelly bean, you try it, and it's bad, which I know in this example it's not, but does that in any way influence the next jelly bean? Like, the next jelly bean's like, you know what? I'm going to be good because that last jelly bean was bad. No, it won't. So these are independent probabilities. As in, if one jelly bean is good or bad, it will not influence the probability of the next jelly bean being good or bad. Charles, good example right there. If we say like in this bag, 75% are good, then the probabilities would change. If it's like a thing from the factory and it says like our numbers are that 75% are good and you're getting a random assortment of our jelly beans, then we would assume you know what jelly bean I don't mind, really quick on that? I don't mind the toothpaste jelly bean. I don't see hypothetical question if there was a fixed amount of good jelly. Exactly, Annabelle. Yep. Which we wouldn't, that's a good thing right there. Then the probabilities would change. Annabelle, 500 points. That is a good way of putting it. If I know grass isn't that bad either. One of my friends told me grass tastes bad. I disagree with him. I'm not out there eating grass, but he's like, grass tastes bad. And I was like, I don't know. You crazy, Rick. And he agreed, but yeah. Prairie Bobcat in the lead, Smart Ferret, Polite Rooster, Glad Dragon, and Rockstar Finch. Great job. Next question. Here we go. So the probability of getting a multiple choice question correct is 80%. With 5 questions, what are the probability you get at least one wrong? 90 seconds on the clock. Ooh. There's like a dog food and like a something. So the first thing I would write down while solving this is I'd write down the probability of getting it wrong is 20%. So if you get at least one wrong, that means you didn't what? So finish this sentence. If you get at least one wrong, that means you didn't what? If you get at least one wrong, that means you didn't get what? This will solve it if you figure this out. If you get at least one wrong, that means you didn't what? How's that sentence finish? I got at least one wrong. Well, then you didn't do this. Ooh, no one's... I didn't get them all right. So what's the probability of getting every single one of them right? What's the probability of getting every single question right? You can put in the chat right here the probability of getting every single right. Oh, earwax. We should rank worst jelly beans. What's the probability of getting every single question right? Well, you're on the right track, Fran. Great work, Fran. You're on the right track. It's probability of getting a question right. Oh no, Troy, no! People are getting mad about the earwax jelly bean. This is a good, tough question right here. Great job, Clara. Clara doing a great job tonight. Clara, this 500 points goes up to Clara. Clara's given a ton of great answers tonight. Just love doing random shoutouts every once in a while and throwing some extra points. But Clara, keep those great answers coming in. So the probability of getting it right, we actually didn't need that probability of getting it wrong. I was working through in my head. Probability correct is equal to 80%. So, ooh, in 6th place, remember 30 for first place, 20 for second place, 10 for third. So probability of at least one wrong. So let's say at least one wrong. Or all correct. What does this equation equal up to again right here? So we got the probability of at least one wrong or at least, or getting them all correct. What is this? Because one of these things must occur. Yep, of course. Yeah, I love doing that. I make a tiny bit of money from the YouTube channel, like $100 a month or something like that. So I just want to, I do KAHOOTs for other classes too. So not trying to make money. So if you see an ad on a video, thank you, but we don't put them on class or anything, just on some help videos. It also reaches a wider audience because YouTube's like, oh, here, we want to show you a video with an ad on it. And then there's the theory that YouTube's going to literally monetize everything and then you won't, yeah. It's like, well, but no, it's not a flex. If that was my only source of income, I'd be in trouble. Then I probably wouldn't be doing KAHOOT surprises. At least one wrong or all correct. So what can I change the or to right here? What can I change the or to right here? And I'm fine if you use an ad blocker. That's fine with me. What can you change the or to right here? Well, we don't want to change it to an and because both these things can't occur. So, oh, cool, Troy. That's awesome. 100 won't pay them rent. We can change the or to a what right here? You can change the or to a what? Not an X. If you see the word or, wait, and let's go look at the formula sheet. If you see or, what should you change the or to? The formula sheet's got some help. Start spamming the chat with it. Looks like a lot of people didn't know. Leo's got that ad blocker too. Change it to a plus. Leo's giving some ad blocker advice right there. And so change it to a plus. No, don't change it to an and. The and is a whole different thing with the independence multiply. Don't worry right there, 100 points. The and is a multiply, so use your formula sheet right here because we're going to change this to a plus. So we're changing this to a plus because it's or, because you can't have both these happen. You either get at least one wrong or you get them all correct. So now we need to find out the probability of getting everything correct. What is the probability of getting them all correct? So what is the probability of getting them all correct? No worries, this is the practice. What is the probability of getting them all correct? So you would need to get the first correct, and the first correct, and the second correct, and the third correct, and the fourth correct, and the fifth correct. They go right here. And then you take and subtract. And that's going to be the answer. Gotta do the minus on it. So great job, and subtract from 1. And so a lot of people are seeing it. Try doing it in these steps. The more of these you practice, the more you get to the test. It's an easy question. Do realize the whole test is not over this. I think a lot of people stress about this one question and then don't look at the rest of the test. So this is just one type of version question on the test. Christian at that pint hype level. That's from Miniterm, pint hype. So you can even check your pints right there. Next question. Let's go to leaderboard. Here we are. Oh, shake up of the leaderboard. Shake up the leaderboard. Well, Claire, right answer is right answer if that happens on the test. Awesome work right there. Let's go to the next question. Here we go. Smart Ferret, good job. Question number 6. Which of the following is a rule of probability? So we have 5 rules of probability. And the 5 rules of probability are, all probabilities are contained between 0 and 1. Rule number 2, the set of all probabilities has to add up to 1. Rule number 3, the complement rule. 1 minus an event is the probability of its complement. Like if it's going to rain today is 20%, not rain today is 80%. Rule number 4 is the addition rule, which we were just covering a lot of. And rule number 5 is the multiplication rule. So with this right here, what are these other conditions on here? The QQ straight enough, no outliers, plot doesn't thicken. What are the other conditions on here? I love to throw in some review for other things. What's this QQ straight enough, no outliers, plot doesn't thicken? That's cheating. Like, don't tell them the answer. These are the regression conditions. Oh, sorry. It looks like someone passed. Sorry to hear that. QQ straight enough, no outliers, plot doesn't thicken are the regression conditions. And our hearts go out to the, sorry to hear that. Oh, bad news right there. Next, leaderboard. Smart Ferret holding on to the lead. Polite Rooster and Rockstar. This is a close leaderboard. Woo! Competitive game. Sorry to hear that, Young Dolphin. Sorry to hear that. Next question. Here we go. A researcher selects the first 20 roads next to their house. So now we have some sampling distributions, some sampling questions from chapter 10. This is all chapter 10 here for a moment. Really good covering of topics in tonight's video. A researcher selects the first 20 roads. They just walk outside and you say, hey, I was paid to research roads. Let me just take the first 20. So what would this be? What kind of sampling method are they using? Now, some people might say it's clustering. Some did say, but this is convenience. Who can put a definition of convenience sampling in the chat? So who could say convenience sampling is this? So you'd be like, oh, convenience sampling is when the person who's collecting the data doing the research collects how? It's the easy way. It's a non-random. Good answer, Sarah Grace right there. It's a non-random. So convenience sampling is non-random. Great to have you here. We're always free to have some people joining in, learning some stats. So convenience sampling is non-random. We have people just going out and getting the first and easiest things to get a hold of. So this is not good because maybe who knows where they live? Maybe they're like me, they live in the fort and the roads. You know what's interesting? They redid the roads in the fort in like 2015 and they were really awesome. But I feel like they didn't put enough investment into the roads because there's, I don't know. They didn't maintain that quality. So it really depends on where the researcher lives. Lived in the fort, live out who knows where else. Roads could be awesome. This is a non-random way to sample. So not good right there. Anyways, let's check out that leaderboard and see who's in the lead right here. Smart Ferret still leading the way. Polite Rooster, Rockstar Finch, Snowy Panda, and Prairie Bobcat. Let's find out the next question. Here we go. Question number 8. A researcher selects every 5th road in a list of roads. So this, everyone put that 2-letter word in the chat. If you see this, you're just gonna be like, boom, I know the answer. You see this and you know the answer. I'm hoping we have near 100%. I will throw 500 points if less than 3 people miss it. People are already saying that that kth, nth. So technically they would pick a random starting point also. This is a random sampling method. I'm not blocking the answer. Every kth observation. Oh, I'll give those points. I'll promise some points. Great job right there. Awesome work in the chat. Nth right there. You are correct. Excellent work. Oh, no worries. Annabelle, that's fine. We're still throwing those points out. Great work on it. It is every nth. And we have to notice that we're talking about systematic right here. Systematic technically has, and great job, Kristen, right there. Systematic is choosing a random starting point and then taking every kth observation. This is a random sampling method. Put these on flashcards. What wording would make this stratified? Maybe we'll see a question here coming up next. Let's continue on, and maybe there'll be some stratified coming up soon here. So once again, just take a breather. People are ready. People are ready. Have these down on flashcards if you're watching this later. So check this out later, put down the definitions, and practice different ones. Fast Otter, looks like they're coming for you right there. Watch out, Fast Otter. Here we go. Swim away fast. Next question. A researcher lists all roads and then randomizes it, the order, and then selects the first 50 roads. We put this on a test one time, or a version of it, and a lot of people got it wrong. Now, process of elimination might help you, because I've got only so many questions in the KAHOOT, so I can't ask the same question 10 times, or can I?
Or can I?
It'd been better if I was ready to do that. But let's see. What do people think? So, it's like I take... Well, didn't want to block the answer. People thought stratified. And some people said cluster. We'll see this in a moment. So this is simple random sample. Simple random sample is when everything in the population has a what chance of being selected. It's like I take all the road lists and I put it in a hat and then I just take out the first 50 like that. Simple random sample. Simple random sample, everything has an equal and likely chance of being selected. If you go to the registrar and tell me, you say, give me 100 random students. Great job, Michelle, right there. Everything has an equal and likely chance of being selected. What if 50 was less than 10%? Well, that would be good for our summary statistics. Great answer right there. Great job right there. Variance right there. Variance. Call it variance. Make sure I'm pronouncing correctly. But with this right here, simple random sample is when everything is given a number sometimes, and then it has an equal and likely chance of being selected. It is still a simple random sample. If I go to class and I say one person is going to win a new iPad, and then I have everyone put a name in a hat and I shake it up and I draw a name out. What do you, has anyone ever seen where you have the bingo ball type stuff? It's not necessarily bingo, but they roll it around and then they draw out a number and they say you're the winner. That would be an example of a simple random sample. Kevin, great questions. And we're about to see some of that. So we're going to see some cluster and stratified. It might be the next question. So get ready. Let's see. Leaderboard might shake up. Leaderboard is locked, but Prairie Bobcat didn't get the points. Don't worry, Prairie Bobcat. It's going to be a close game, I think. Here we go. Next question. A researcher selects their sample based on the percent of highway roads, country roads, and city roads, acknowledging a difference. I know some people instantly clicked the answer because they saw some keywords. Now, the question might not use those keywords, but this is the way we know it. Does anyone who feels, put a capital YES if you feel super safe about your answer. We reviewed this a lot in class, and they're selecting it based on percent of highway, city, and country roads. It definitely gives a hint, right, Avery? That hint might not be on the test. So when we stratify, we acknowledge a difference. Now, what would be the keyword with census? What would be the keyword for census? When you acknowledge a difference, which means you're saying country roads are different from highway roads, different from city roads. What would be the keyword with census? We might see a census question coming up. Oh, wait, with, oh my gosh, with cluster. Was I saying census? I think Streaming and bright lights have gotten to me. Cluster sampling will always have a census when we do it. Cluster sampling will always have a census. Does that make sense? We are going to take a group and take all of that group. If this was a cluster sample, what would we be doing to at least one of these groups? We'd be going to, like, let's say highway roads and doing what? So if this was a cluster sample, we'd have to think of these three groups, which they should be randomly put in, which they're not. And then we would go to highway, which is one of those groups. And Allison's saying it, we'd take all highway roads. And that's kind of the key right there, is when we think about cluster sampling, which is on the screen right here, you don't take randomly from the groups. You take all of one group or multiple groups if you're taking multiple clusters. So you'll see some clusters coming up here in a moment probably, so get ready if you're practicing. I don't think I'm mean, but a few more tricky questions coming up. Let's check it out. Leaderboard shakeup. Snowy Panda jumping in there to the lead, right on the tail of Smart Ferret. Let's go to the next question. A researcher decides to take 5-mile segments and sample each mile segment in within the 5 miles, performing a census on each of these somethings. I can't say the last word. So these are 5-mile segments that they go to and take it all at once. I'm not blocking any right answers. Right here, Snowy Panda, good work. So it sounds like each of those 5-mile segments is a what? Like they're just saying, let's take all of that 5-mile segment. Let's just take all of that. Each of those is a what of roads. And there's no difference here. It's just a 5-mile section, a 5-mile section, a 5-mile section, a cluster. Great work. Does that make a little more sense what a cluster is? A cluster is just taking a whole bunch at once. In cluster sample, we do not do this. In cluster sample, we do not do this. The groups are just random. The groups are random, and we do not, this is just random groups. This is 5-mile section of road, 5 miles, and we're just taking 5-mile clusters. Cluster. I am not doing what? I'm just going to take another 5-mile cluster. I'm not doing what? Another 5-mile cluster. Another one. I'm not doing what? You just take a whole bunch at once. You're not doing this, though. There's none of this, though. Someone say in the chat to differentiate it between the other one, which I won't say right now. You're not doing what between your clusters? It's just, you're not acknowledging, great job out there, Kayla. You're not acknowledging a difference. It's just 5-mile section of road, take it. 5-mile section of road, take it. There's no different. It is still random. So the clusters are taken randomly. Great question right there. And answer, Priya. The clusters are taken randomly. So you don't go out and take the first 10 clusters near you. Like, let me just go out and take the first clusters of road near me. You still go out and take random clusters. Exactly. So great answers and great practice. Good work. Leaderboard doing great. Next question. Here we go. The researcher takes too many city roads in their sample. What kind of bias is this? Too many city roads. You're welcome. Great work. Too many city roads. What kind of bias is this? Too many of something. Now you might say, wait a minute, too many. Is there a bias when we have too many? Well, if you have too many city roads, wouldn't that mean you have too little of something else? And that kind of tells you what the answer is. Too many city roads would mean you what? Too many city roads would mean you undercovered. I don't know if the roads can really give response bias. Response bias is the way in which the surveyor influences. Oh no, sorry, Avery. But the way in which a surveyor can influence the results. What is response bias? That's like if I ask you, do you think it's fair that, like you're in college, right? So if you're 18, you could go to war. But guess what? When you come back from war, you can't have a beer. Do you think we should lower the drinking age? So what's the real question right there? What is the real question? Like I'm saying, I need to know your opinion on drinking age because do you think we should lower it? Because right now you could go to war, but you can't drink a beer. So response bias is the way in which the surveyor asks questions or acts could influence somebody to answer differently. Convenience bias is from convenience sampling. So the first thing that listed, like taking the first few roads near you, convenience sampling is convenience bias. Exactly framing, exactly Troy, 100 points, framing a question, giving like it's really, I was reading a survey today and I was like, I was not happy about the survey. It's a bunch of really bad research done horribly. Non-response bias is when people who don't answer questions may differ in the way than those who do answer questions. So if you're, calling about a sensitive topic and people don't want to talk to you, well, then maybe the people who don't want to talk to you about said sensitive topic might differ. Under coverage bias is when you leave out a certain group in your population. So my favorite example of that is like someone put an R or a D in the chat. Like I want to find out UT's opinions on, let's say, marijuana legalization. I think Supreme Court or someone's looking at that lately. We talk about, I don't give opinions here. So we're going to go to the college Democrats and we're going to ask them, what's your opinion on this? We're going to go to the Green Party on campus and say, what's your opinion? And you'd say, well, we're not getting enough of the population being represented. Now, what would be a good way to maybe make sure if UT is, let's say, 40% Republican, 40% Democrat, 20% Independent, and if that's what's going on right there, what would be a good way to make sure we kind of represent and don't do some undercoverage by not getting too many Republicans, too many Democrats, too many Independents? What sampling method could we use to guard ourselves against undercoverage bias? To make sure, we need enough Republicans, Democrats, and Independents to make our sample look like our population. What would be a good way? Priya, that is correct. I mean, one is the sampling, one's the bias. That is correct, Priya. What would be a good way to be like, we have 40% Republicans, 40% Democrats, stratified, Kaya. That is correct. So, and that's what it's going to, not quite equal, but like representative. So we want our sample to be representative, and we could acknowledge a difference and say, in our sample, I want there to be 40% Republicans, I want there to be 40% Democrats, and 20% Independents, if those are the numbers for UT. So then we are acknowledging a difference, and we're sampling according to that difference, and that's what stratified is. But if I went to classrooms and said, I'm going to talk to everybody in this classroom and get their opinions, and I go to everybody in this classroom and get their opinions, that's an example of what? I've totally reworked my sampling method here to say, let me just go to classrooms at UT. I'm just going to select 40 random classrooms and talk to every student in those classrooms. It doesn't matter what classrooms they are. That's clustering. So notice how I'm not talking about a certain like engineering or this or that. I'm just saying, and not if I go to the first 40 classrooms I see when I get to campus, that's more of a convenience clusters, which is not a good combo. Never do convenience. But if we just say we're going to go to classrooms and speak to every student in the classroom becomes the cluster. Are classrooms randomly assigned? That's a little bit of a problem with an assumption with your clusters being random put together clusters. Who feels like they're starting to understand the difference between stratified, which is maybe I'm like, I have Republicans, Democrats, and Independents, and I sample from those strata, or cluster where I'm saying I'm going to take whole classrooms and speak to every student in those classrooms. I'm not talking any differences. I'm just saying classrooms of students. I want to understand students' opinions, so I'm going to go to classrooms. It takes some practice. Try using the examples. I do some other ones in videos, so I try to mix it up, throw some social issues in there. I love social psych, so fun stuff. Take some practice. Try doing some examples. Good review right here. Oh, leaderboard shake a prairie bobcat is back, but Glad Dragon, we're glad to have you here. We hope you enjoy the show. It's good to have you with us, even if it's just for a while. The researcher collects roads around their house. They're their house. The researcher collects roads around their house. Kind of like the first 10 roads they have access to. The researcher collects roads around their house. That says around. I promise you, it says around. They're there. As the English majors say, they're there. Right, Kristen? Convenience bias. This one's pretty easy right here. Convenience bias. Cracking people up in the chat. Kind of sounds convenient, right? Convenience bias is convenience sampling. Same tomato. Put on your 3D glass. You only see it with your 3D glass. It's a magic eye trick. I promise you. Okay, next question. Here we go. Let's go on. The list of the researcher, the list of the road the researcher has access to samples. It might lead to undercoverage. Priya, to the previous question, it could lead to undercoverage, but they're doing it in such a convenient way. The real issue would be that they did convenience sampling, convenience bias, which would be non-representative, and they probably undercovered. It's kind of like this creates this other problem. That is correct. Priya, good point. Good point right there. What is the key word right here? Who knows the answer to this question? Ooh, wow. That's for some points.
Wow.
The ones they have access to, the ones they can sample. So be careful, kind of warning everybody. This was throwing off at the sample space. Oh yeah, sample space is the things that can occur in the probability space. A sample space looks like the following. So if you want to know what a sample space is this. The sample space is the list of all events that could occur. The sample frame is everything we can sample from. Does that make sense? This is the sample space. Sample space is from chapter 12 when we do what's, and it's right there. Sample space is from chapter 12 when we're doing what? What is chapter 12 on? Chapter 12 is all about what, and that's where sample space is used. It's this P word right here. Sample space is from chapter 12 where we're doing what? Probabilities, pretty great work. Chapter 12 is sample space with probabilities. Sample frame, I like to think of it as like a picture. So I think of a picture, and if people, they don't have to be people. I knew it that you would do that to me. People, if they are here, they are in your sample space. Now, this doesn't mean they are in your what? If they're in your sample space, that doesn't necessarily mean they are in your what? If they are in your sample space, oh, it's top tier. We are all, this is 10 years of art school on showcase for you right here. I worked hard at it. I draw all those people identically. If they're in your sample space, it doesn't mean, or sample frame. Ooh. Oops. If they're, Gavin, great to see you here. If they're in your sample frame, it doesn't mean they're in your sample. One of my favorite examples is you walk into Hodge's library. If you walk into Hodge's library and you want to talk to students, and you're just going to hang out inside of there, who's in your sample frame? It's one of my top examples. We try to conquer one big example. So you walk in to Hodge's library. Who is in your sample frame? Everyone who's inside there, right? So but make sure I think Kristen's saying that, right? Everyone who's in the library. Does that make sense? If they're in Hodge's, you could talk to them. And I think that's the hard part for people about the sample frame. Is it's not everyone you speak to. Now, theoretically, someone could say, what if I do? I put it over the loudspeaker, yell out your response, and I'll record it somehow. I don't know. Maybe you can do that. Your sample is everyone you speak to in Hodge's. So the people you talk to in Hodge's are the ones you sample. But the sample frame is everyone you could possibly ask inside Hodge's. Like, just think anyone walking near you is someone you have what to. So use the word in the slide. Everyone walking around you is someone you have what to sample in Hodge's. It's like, great job. And the population probably all students, great job. Everyone you have access to talk to. Like, you could talk to that person. Now, if you do talk to them and they give you an answer, that's your sample. What if you say, hi, I had some questions about this, and they look and they say, I don't want to take that survey. I'm out. I don't like that survey. I'm out. What bias did they just do? They say, I don't like to answer those questions. You say it's Smoky Appreciation Week, and they say, I don't like dogs. I don't want to answer your survey. You're like, oh, okay. Okay there. I mean, it's okay to not like dogs. I'm not trying to be mean to anybody. We're cool. Non-response. That is true. Non-response. Smokey's awesome. Especially Smokey comes and visits you. Who would ever say that? I don't know. No one here at UT. Everyone loves Smokey. 100 points for Smokey in the chat. Continuing on right here. Let's do it. Oh, leaderboard shakeup. Glad Dragon is back. We're good to have you with us. Even if it's just for a while. The roads, the researcher samples. The roads, the researcher samples. The ones they actually sample. The road, the researcher samples. It's as easy as it sounds. Go Vols right there. Vols rock. I should put the roads, the researcher samples. The roads, the researcher samples. Fixing something here. Ah, I can't do it because it has a space. Well, The roads the researcher samples is the sample. The roads the researcher samples is the sample. So I promise you it's that simple. I think sometimes we overcomplicate things. We don't ask them anyways then. Some are good answers. The roads the researcher samples is the sample. It's like, you trying to trick me, Brian? You trying to trick me here? You saying the people we sample? That's our sample. What if you see it's a sample, it'll usually have a what with it. 4-letter word. Supersize it, what? 4-letter word. If you see it's a sample, it'll usually have a what with it. Man, I missed that as a kid. You go to McDonald's, you say super what it? You say fries. If it's a sample, it'll usually have a what with it, which is N in notation. If it's a sample, it'll usually have a what. It could have bias. We'd hope it won't. Juanita, your answer right there. It could have bias. 100 points, Juanita. It'll have a size. A size. P hat is the sample proportion. But if it's a sample, I was saying supersize. It'll usually have a size, like an amount we sample. We usually sample amount N. Does that make sense? So N in notation is the size of the sample. Oh, parameter of interest is what we're interested in learning about. And population is what we are interested in learning about. Now, watch out. Be careful. I think we're about to see some streaks lost. So we read these very carefully. Here's a suggestion. If you're doing well, be very careful on the questions to come. Be very careful. If you're doing well, you get ready. Here we go. Here we go. I'm more of a big gulp kind of guy. Here we go. The roads the researcher wants to understand. The actual roads. They say, I want to understand roads in Knoxville. I want to understand roads in Knoxville. The roads the researcher wants to understand. I can't imagine their attentions. The roads the researcher wants to understand. I'd almost say they're interested in these roads. What if I said to you, the students you want to understand? If I said, let's go to UT and talk to students, the students you'd want to understand are who? No, don't worry. The students you'd want to understand, you'd say, I want to understand who. Let's go to UT and talk to students. What are the students you want to understand? We're just putting students in here. The students you'd want to understand are who? Well, they'd be the population, and it'd be Tennessee students, right? You'd say, I want to understand Tennessee students, right? So Tennessee students would be your population of interest. Now, here's what a parameter is, though. A parameter is the thing we want to understand about the population. We say to students, how much do you love Smokey? Smokey's awesome, or Smokey's really awesome. So put it in chat right now. Take a vote. Here, we'll do this. We'll do it as a vote. Here's the parameter of interest. We're going to take an estimate of it. Awesome. We'll put super awesome. Shout out to Smokey right here. How much do you love Smokey? He's awesome or he's super awesome? So the parameter of interest is rate Smokey. Oh, Luke, that's so kind of you. Parameter of interest of Tennessee students is, how much do you love Smokey? Awesome or super awesome? He's been slacking lately. So our population is who right now? You could think, like, let's go in the big sense. Our population is who as I take this poll. As I take this poll right now, the population, I mean, you could, but kind of go a little big for it. The population is who? The population is the group I want to understand. Tennessee students, UT students. I want to understand UT students. Now, there might be some bias to what we're doing right here. Like you might say, is this really a random selection of UT students? Because we're set to a 1 students, right? So we'll just say we want to understand UT students, right? You about loving some go vols right there. So we want to understand UT students. He loves the volunteers. So I've asked you a question, which is the thing I want to understand about the population. This question I've asked you, and the answer to it is an estimate of the what. Now, it's not the truth. It's just an estimate of the what. Like I'd say, I estimate around 77% of UT thinks Smokey is awesome. That is a sample statistic, but it's allowing me to make inferences about the what? The parameter of the population. Does that make sense? The 70%, 77%. Oh, well, you're welcome. Anytime. I think we just had a visit from a random individual. Let's throw some 500 points. That's why if you ever see someone random in the chat, they're always welcome to be here if they're throwing some positivity towards us. Vinegar right there. Good to have you here. Some 500 points for random person dropping in. We like the positivity. You're welcome to join in, practice some stuff. Didn't know if you're one of our students or just practicing. Maybe saw some 201. But hey, shout outs to you. You just got everyone 500 points. We like that right there. It's public right now. Which is out there on the internet. So no, we appreciate it. We had Calzone Tyrone was in our first Kahoot ever. So yeah, no, we always appreciate it. So mods, if you ever see anybody who's doesn't have a mod name, they might be our student, they might be in another section, but if they're here doing if they're positive and stuff, they're always welcome to be here. And we love that. You're positive, you're welcome to be here. You're welcome to practice and ask questions if you got stats questions. Going on to the next question right here. Whoa!
Wow.
The heck? Leaderboard. Yeah, no, YouTube will do that. We've had people join in and be like, what the heck is this? Like, which they kind of said to start. I was keeping an eye. I was watching. But they were great. They're great. Glad to have them. Yeah. Whoa.
Wow.
Next question. The researcher wants to understand the average amount of potholes per mile for all roads in Knoxville. You're welcome, Crispin. Researcher wants to understand the average amount of potholes. Oh, it kind of sounds like it's what they want to understand, right? A little bit of review. And now you know you got this one right? I like to do... Kahoot's been kind of practiced such that maybe if you get something wrong, there's kind of a redemption moment. Great work. If you ever have suggestions like soundboard stuff, I've got a whole panel of Mewbot saying things. Oh no, we got this nice music. Why have I not clicked this? This is Josiah Wilkinson. Amazing pianist playing a little Coldplay for us. Forgot I had this on the soundboard. Beautiful music by Josiah. Shouts to Josiah. Smart Ferret in the lead. I'm on the way to leaderboard. You got this, Michelle. Not that I'm rooting against anybody, but Michelle, it's close. Let's find out who wins right here with the next one. Here we go. Next question. And please make sure to email me if you win. Here we go. Probability of making a shot is 0.30. What's its complement? You got this. Quick question. Now this relates to P and Q. If I tell you P is 0.2, you say Q is 0.8. If I say P is 0.1, you say Q is 0.9. If I say P is 0.6, you say Q is 0.4. P and Q are complements. When we say the complement, it's not like you're doing great, which you are. When we say the complement, it's just 1 minus P. So, just trying to say. No, Leo, no misclicks. No misclicks here. P and Q are complements. And do know your formula sheet. Great job right there, 43. 1 misclick by Leo, 100 points right there. So do know your formula sheet. The very start of this review, we went in and did formula sheet practice. So make sure to know your formula sheet. I clicked the picture instead of the answer first. Yeah, you got this. And once again, it's the exam that matters. Rock knows everything else.
It doesn't matter.
We need more sounds on the soundboard, but Rock, you're always doing great. Next question. Here we go. Great work, everybody. We're doing a lot of review tonight. Here we go with the next question. Here we go. The law of averages is fallacy. The truth is what? Now we have a name for this. It's basically telling you this. What is the truth? Oh, slow answers. There are some other truths down here, but law of averages say that if you flip heads a whole bunch of times, tails is due to occur. Or if you've been on a losing streak at the casino, you're due for a win. It's also called gambler's fallacy too, law of averages. It's not true, and I can't appear because I'd be blocking the right answer. Past events do not influence independent trials, and this is called the what. To say that in the long run, we will see the true probability of an event. This is also known as what? Avery knows some gambler's fallacy right there. In the long run, we will see the true probability of an event. Then what is that called? In the long run, we will see the true probability of an event. Like over repeated trials, and it looks something like what? Over repeated trials. God, they were a lot of fun. I'm glad they swung by. They were making some jokes. Got like a 50-50 coin right here. In the long run, law of large numbers. Law of large numbers. So if a coin is a 50-50 coin, which we would assume is true, hypothetically speaking, over the long run, repeated trials of flipping that coin, because in actuality, the first time you flip the coin, it must be either 100% heads or 100% tails. And so what we would have right here is different coins. There's actually a bunch of pictures if you look online at this. Is this econ the long run? It all converges, Leo. I won't name the student yet, but I am not joking. I need to ask them if I can just read their text. Like, I'm not going to read their name right now, but I want you to hear this. This is a student. I'm not going to name the name. But the student wrote me and they said, make sure I don't say any name or anything. I just had an interview and they asked me how to interpret R squared in regression. And then they also asked when to use the median instead of the mean. And I only knew the answers because of this class. Update on interviews. The guy, because then they messaged later, update on interviews. The guy who was asking me in the interpretation said I was the most knowledgeable person on statistic interpretations that he's interviewed. And I got the internship. So huge shout out. Just a big, I'm so proud of my students. Like, we practice these things for a reason. We're not here to solve math problems. We're here to learn what this stuff means. And there's application to all of this. Ken Baker is awesome. Shout outs to Ken Baker right there. Ken Baker, he's such a nice and funny guy. Shout outs to your favorite teachers always right here. We're here to spread that positivity. Ken Baker is an absolute pro. And I'll say this, I have an affinity towards the Haslam College of Business, but I'll say this, Haslam College of Business wants you to succeed. And we are definitely, like, I got a Haslam College of Business mouse pad right here. We're all about students here. So a lot of great educators in the Haslam College of Business. Thank you, Kristen. Yeah, he is so good at teaching. Yeah, Ken Baker is a pro. So I hated my high school microeconomics. Oh no, yeah, check out Ken Baker. Shout out to Ken Baker. I'll tell him he's getting some shout outs. Eric Kelly's great. Worked with him. Laura Cole. Has anyone had Dr. Laura Cole or Angel Norman? I'm about to shout out every teacher. Mark Collins, Kim Sims right there. Shouts to all your favorite teachers. A lot of them are doctor. I'm not a doctor. But a lot of them, like Dr. Laura Cole and Dr. Ken Baker. Dushan right there. I do not know. I'm gonna go back and be like, I don't know anybody. I'll walk around and they'll be like, sir, who are you? And I'll be like, I'm Brian. And they'll be like, no, Brian Stevens in Texas. I'll be like, I'm Brian.
I'm Brian.
Okay, let's get serious. Ava Cowley right there. Good stuff, Dr. Cowley. I think I know Dr. Cowley. Tiny Brian cameo. Continue on to the next question right here. Thank you, everyone, for all the positivity. I don't know. I promise I am not full of myself. I'm very in a constant state of trying to improve what I do. Sorry, we'll finish the good. We need to finish. Focus, Brian. Someone saw where we've progressed because they saw us like 2 years ago and they saw what I did during the symposium. They said, you made so many great improvements. So I'm always trying to make this better, and we're going to beat the internet one day. Here we go. The next question. Let's do this. We know freshmen at UT is 20%. We sample 200 students and 30 report being freshmen. What is N? Notation quizzes right here. Know your notation. Know your notation. Know your notation. Know your notation. What is N? N is sample size. Know your notation. We're back doing notation review right here. Know the notation. The formula sheet is your friend when you know all the notation. It's your enemy when you don't. N is what? Tell me in words what N is. Well, people got it. I'll say it then. Because usually if people get it all right, if everyone gets all the answers right, then usually I'll say the answer. It's sample size. So you're just saying, how many did we sample? But be careful. These questions are about to get a little tricky because some of the terminology is very similar. Here we are with the leaderboard. This is a crazy shaker. Mystery Fox. I know, like, Ferret goes like, cha-cha-cha. Bobcat goes like, wow. But what the fox says is a bit of a mystery to me. Let's continue on. Here we go with the next question. We know UT is 20% freshmen. We sampled 200 students and they report being freshmen. What is P? What is P? If you know this, it's very simple. What is P? I'm sorry, Kristen. Old memes. If it's a 10-year-old meme, I know it well. New memes, I don't know. I don't keep up with the tic-tac-toes that the kids are doing. Yeah, I know, right? I'll just start going like, Maya he, Maya ha, Maya he, Maya ha ha. If you know that, I mean, you might know it as a reference. I was around when that happened. It's good stuff, though. So what is P? What is P? What is P? What is P? What is P, like in words? A few people got this wrong. What is P? Oh, he's good. He's a good singer. Chocolate Rain Guy. What is his name? He's really good. He can sing really. Faison, or I'm trying to think of his name. He's really good. Like his voice is amazing. That guy is wow. And he can sing really well. P is the true proportion. A few people got it wrong because they put what is 30 in the above problem. He's really good. I'm trying to think of it. Tay Zonde. Yeah, he's really good. P Hat, great job, Pri, right there. P Hat would be 30 over 200. He is an incredible singer. Tay Zonde. He's a really good singer. Check out his stuff. Check out his channel. He's really good. So 30 is X. And 200 is N. And people are calculating P Hat right here. When you hear P, that is the true proportion. It means who would be giving you this number. If you were to get this number, which might not be accurate, who would be giving you this number right here? Who at UT would probably give you this number if it's the truth? If I say we know this, thus it is P. So if this is the number you're getting, probably would say in the question, you got this from the who. Well, it is for the population, and you might get it from who, where, what. So maybe the know-it-alls, maybe the registrar or someone, right? Does that make sense? The registrar would say to you, UT is 20% freshmen, and that's a fact. There is no sample size for that because this is for the what of UT. Since it's P, and I think Avery said it, for the population. So this is for all of UT, and it's just made up for the problem. 20% is freshmen. Know the difference between that with P Hat, where the Dean of Admissions, great answer is right there, Kristen. P Hat would be for the sample you took of 230, and that is 30 over 200, which would be P Hat right here. A few people answered that. A few people answered 30, which is X. P must be contained between what and what. A good note, P and P Hat must be contained between what and what. Sorry if you answered 30, but 30 can't be an answer because P and P Hat must both be between what and what. 0 and 1, because it's a proportion or a percent. And then exactly, great answers right there. P must be between 0 and 1. Next question, good review. Leaderboard shakeup, Prairie Bobcat going up right there. Great work. Next question. UT is 20% juniors, from 80 students, 30 are juniors. Find the mean of the sampling distribution. This seems really complicated. If you have your formula sheet, it's really easy. This is the sampling distribution of the sample proportion. Can anyone put one letter in the chat? Because what is the answer? The mean for the distribution of the sample proportion is the what? One letter in the chat gives away the answer. One letter in the chat. Kristen, 100 points. That is correct. Clara, great job. Formula sheet. We'll look at the formula sheet here in a second to see how we got this answer. It says, find the mean of the sampling distribution. Great work. The sampling distribution right here of the sample proportion is the following line. You'll notice that it says the mean for the distribution of the sample proportion is equal to P. So then the question becomes, oh yes, formula sheet can be very helpful if we can read it. And I know it takes a lot of practice. Maybe we'll do a stream this week on reading the formula sheet, just do a few things. I think I got a little sunburn today. Feeling it. Yeah, I did. I should wear sunscreen. mu p hat equals p. So the mean for the distribution of the sample proportion is equal to p. And so all you need to figure out, and great job right there, Kristen, in the chat, we need to figure out what is p. We know UT is 20% juniors, so p is 20%. So the way this works as a problem is if you know UT, no, Maria, me too. If you know UT is 20%, how do we know when to use proportion or mean equals to when it's not stated in the problem? Questions would say things like this. So I know the previous question is, what is the true proportion? So, Troy's pointing out right there that true proportion here is 20%, and that makes it the mean for the distribution of the sample proportion. So the question would ask something like, what is the mean for the distribution of the sample proportion? And we are doing right here a proportion. So it's usually questions state, find the mean of the sampling distribution of the sample proportion. Econ Grace just got released there. Go check them out. So Sarah Grace Parker will be doing more practice here, but good questions. The problem will state it directly though. I have a character limit on Kahoots, so if my questions are a little short, I'm sorry, but good questions. 100 points, Sarah Grace right there. And next question. Leaderboard shakeup, amazing Jaguar. Let's see who wins. Here we go. We know UT is 20% freshmen. We sampled 200 students, 30 report being freshmen. What is P hat? Great job, Sarah Grace. What is P hat? Now, we reviewed how to do this. Who can put the equation of P hat on the chat? Geology exam almost 2 weeks ago. Oh, no. Yeah. Our graders have been really pretty good this semester. If you ever have a question about grading, great job, Priya, right there. X over N. X over N. So you need to find the number of successes over the number of trials, which is 30 over 200. Great work, great practice. Shout outs to all the graders. Usually it's a graduate student, or some people grade their own stuff. Oof. So there's the equation in the chat. We're wrapping up. We're doing some rapid fires, so don't leave yet. It's almost over. Tiny Brian will announce the winners. Smart Ferret in the lead. It's a close call here down here, though. You never know. Nothing hurts to excel class graders, man. Oh, no. Sorry, Leo. Avery, can you win? UT is 20% juniors. From 80 students, 30 are juniors. From 80, 30 are juniors. Find the sampling distributions standard deviation. What is the standard deviation? Quote 191. X is the number of successes. In this example, X is 30. Good question, Becca. 100 points, Becca. X is 30. We have Mubot putting the equation in the chat. X is 30. Is extra credit muted for everybody? I think I have muted. P times Q over N square root. P times Q over N square root. Oh, no, it's all right. Well, I think there's some numbers we could eliminate. If you look at this theoretically speaking, the only two theoretical answers are red and blue. I'm going red. The only two theoretical answers would be red or blue because the other ones are just too big to be standard deviations. Standard deviation is going to be how many units you go up and down on the normal curve. So it's all right if you answered yellow or green, but those are kind of too big to be a standard deviation, especially 0.8. That's a ridiculously large standard deviation. So how do we do this? You ready? Practice it with me. What's the first thing I need to find? And Mubot's going to put the equation in the chat for us. So look at the chat. So Mubot's dropping that equation in the chat. Oh, Troy, it's all right. It's all right. Let's find P. Okay, how do I find P? Help me find P right now. You got this, Avery. Great work, Avery. How do I find P? Someone tell me how to find P. They're saying I need to find P. Mubot's saying P times Q over N square root. Is it? That was pretty... Oh, wait. Oh, my gosh. What did I just find? I made the number one mistake that students make. What did I just find? You are correct. You are correct. You are correct. What did I just find? Very common error that I just did. Parker. 500 points Parker right there. I was just testing everybody so I could... Parker was there they were there to just like help out. So Parker, great work right there. They were there to help out. It was a joke. Haha, funny. Wasn't that funny? P times Q over N. And I should have done where they screwed N. Boop. Double check your work. P times Q over N square root. P times Q over N square root. Yes, there should be scientific calculator. I put the scientific because the proctorial calculator should, yep, I have the scientific. Off top of my senses, one exam gets, no, that's not true. Sorry, Ethan. One exam does not get dropped. Sorry about that. No exam drops. Say to your friend no. If they say yes, then tell me who's dropping exams, because I'd want to know. Knew it. You're like, knew it. Darn it. It should be on screen. Check out the final question coming up. Check out the practice proctorio. I think you still have access to it. If you can't find it or something, if you have questions, I think it's like, does anyone you must listen to Tiny Brian.
Every exam gets dropped. A's for everybody! Yay! Yay!
Tiny Brian, no.
Tiny Brian, no.
It'll pop up. Good stuff right there. Good stuff right there. All right. And here we go with the last question of the night. Everyone ready? I need some eyes in the chat. I'll give you a countdown because there's a little bit of lag. Last question of the night. Tiny Brian says real. But Tiny Brian said it. I got it on stream. Can't listen to that guy. He doesn't know what's up. Here we go. Last question of the night in 5, 4, 3, 2, 1. Here we go. For the sampling distribution of the sample proportion, what is the third condition? We'll see a review of this here at the end. Condition 1, you know it, which is not the answer. Condition 2 is the one where people often think, but don't we need more? The answer is no. We actually violate the second condition. Condition 3, there are no orders to these, but I do like to say condition 3 here for the sampling distribution of the sample proportion is what? You didn't click it quick enough. Oh, no!
I'm in control now. Success, failure. What is large enough N used for? Who knows what large enough N is? And go back and check earlier. Here, wait, I can impersonate Brian for a second. Watch this. Here's my Brian impersonation.
Okay. Oh, yeah, this is a good impersonation. Good. Brian won't mind if I impersonate him for a second here. The sample proportions has success, failure, and Brian reviewed this earlier because I'm Tiny Brian. So,
Here we go. Let me go back to Brian voice.
okay, there we go. And down here, you can see the sampling distribution of the sample mean. With this right, hey everybody, good work right there. And make sure to review these. We reviewed these earlier, so check these out. Sampling distribution of sample mean. Third condition is different. Sampling distribution. Good. Oh, thank you right there.
Yeah, I go back to my normal stuff, William. Yeah, appreciate it. Of course. There you go. Tiny Brian is not leaving the screen. Wait, what? Go back here. There we go. I'll come back. Can I? Wait, where? No, I don't get that. Where's Skeletor at? Yeah, there's Skeletor. I like that. Wait, where's my parrot at? Ooh, this is good stuff. Okay, let's go back. Okay, here we go. Time for the winner. Tiny parrot. Wait, what's he doing? Where's it?
I think Tiny Brian got taken away. I know. He needs to come back. He's off the screen. I'll never find him. I'll be like, I'll do the Tiny Brian again. Good night, Kristen. Good to see you here. Joey, great job. Bye, Kendall. Have a great night. Tiny Brian, you need to go. Your parrot needs to go too. He should show up to class more. He shows up for later examples. Time to study for another 2 hours. Awesome. Take some breaks. Relax. Great job. Bye, Kristen. Great job, Leo. How do you know if the question is referring to sample mean or sample proportion? The question will state, and we'll be reviewing that a lot tomorrow, Priya. That'll be a big question of the day. Is it sample mean or sample proportion? Tiny Brian and his parrot will return for type 1, type 2 error. He shows up for that. I should incorporate him more. He's just got example lectures he shows up to. Those 200,000 Mu-Bucks within reach. Troy, we could make a level for you if you want. But here we'll back to the main screen. You're welcome, Carter. Great job, everybody. It looks like I did get a little sun today. I think I got sunburn on my neck. Yeah, I did. Yeah, I was outside for like an hour and a half, 2 hours. Eee. It was worth it. Got some Pokemon. It's like sunscreen's not the best for you. Sunshine in moderation is all right for you. It's not so bad. I was like, why is it so hot? And I was like, oh, I think I got a little burned. It was cloudy. So windy though. Like sometimes I walk around with an umbrella. People probably think I'm just like, but I mean like, I don't know. It's a good way to block the sun. I don't like hats. I'm not a big hat person. It's Brian's life advice. I'm just not into hats. I'll carry an umbrella and play my Pokemon Go. Kind of tuck it in my arm. My Pokemon. I got a 105 on the econ. Better get something similar on the stats. Oh man, we don't got 105, but you can get 100. Great job, Leo. Give some shout outs to Leo. We're heading off here in a second. But shout outs to Leo and everybody working hard. We're about to have a break. Umbrella is like a body hat. I agree with that right there, Kaya. It's a great way to just be like, got my umbrella. You can stand under my umbrella. Great work. And I know it's almost break. We're gonna have a nice 2-day week or 4-day weekend. Not 2 days. Most weekends are 2-day weekends. But everybody, keep practicing. Show up to class tomorrow. Hashtag show up. We will be reviewing Wednesday. Swing by office hours. Until then, we'll be back. Bye for now, everyone. Pre-order a 20-point curve. Who knows, Parker? The obviously says the probabilities have to perform 0-1 and are inclusive. Oh yes. So to Sarah Grace's question, thank you, Sarah Grace, for asking. We'll head out here in a second. We'll put one more song on here, and then we'll head out. So probabilities, Sarah Grace, have to be, it's saying inclusive. So probability, this is the first rule of probability, is that probability can be as low as 0, which means something can't occur. So probability 0 is like me meeting Deadpool. It's not happening. Probability 1 is like the sun rising tomorrow, means it will happen. So probability, and it would look like mathematically, is contained between 0 and 1, with 0 being the lowest probability of something can never occur, and probability 1 means it must occur. And so it's inclusive, meaning 0 is the lowest value, including it, and then 1's the highest value, including it. So probability is a value between 0 and 1, can go as low as 0 and as high as 1. 0 means something will never occur, like probability meeting Deadpool, and then 1 means it will occur, like the sun will rise tomorrow. Does that make more sense? So it's just probabilities are mathematical values between 0 and 1, including those values. So when it's inclusive, it says it can go as low as this. If you say a probability, it can't go outside the bounds of 0 and 1. With that, awesome, Sarah Grace. 100 points. Thank you for asking. We try to answer everything we can. It is time to head off. Swing by office hours, swing by class. We'll be doing more. Bye for now, everyone. Bye.